they're all, oh, there you go. Haha, look at that. So you should be able to hear me on that one. All right, you can probably just do it out of the laptop. You'll just hear me on that one.
Okay, yeah, yeah.
Thank you so much for doing that, bro.
Yeah, no problem, man. Thank you for being there to
It's been a
help out.
pleasure. I got to talk with you a
Absolutely.
bit and everything. But yeah, man, if there is a good website, I always go with, because the first time I went to Japan, it was my son's graduation. And we were talking about it. My wife, I'm from Nicaragua in Central America. My tickets per head was like 900.
Okay.
Going to Japan was 1,200.
Yeah.
But included, in the 1,200 included round trips, the train pass, and the hotel stays.
Oh, that's not
So I
bad
was like,
at all.
that's fucking cheaper than going, you know. So we went, and there's a website called Trickmasters.
Trickmasters?
Yeah, .com.
Put that in my phone right
And
now.
they have packages. So what it is you put in the package where you want, what airport you want to be, you put the time that you want to stay, and it'll say, for example, 9 days. 3 days in Tokyo, 3 days in Kyoto, 3 days in Osaka, which is the biggest, right? But then once you get the package, so TRPS.
Oh, Trip
Yeah.
Masters. Okay.
Um, so, so they give you this 9 day itinerary.
Yeah.
Then once you open the itinerary, you say, you know what, I want to spend only 1 day in Osaka. You can change it.
Okay.
And then it'll tell you to choose the hotel you want to stay at. So that's the only caveat, because you have to kind of know at some level, do a little bit of background, because we just pick hotels. We end up in Roppongi Hills. But if you know the area, you can say, well, maybe I want to stay over by Asukasa or something like that,
Right.
right? So you choose the hotels you want to stay at. And some hotels added breakfast included.
Okay.
And then again, the rail pass for like $1,200 round trip. And I was like, I didn't have to worry about like making reservations or any of that shit.
What's up, MJ? Avalon, what's happening, man? So that's the way to travel right there.
Yeah.
How you feeling, brother? Good, man. You good?
Yes, sir, we here.
Yes, sir. Hey, it's been a long road, but we here.
I'm going to stop my recording. Is there a particular time you guys want me to start recording, or rather streaming?
I think the
We
first.
start here at 10:30, right?
Yeah, essentially, yeah. We can probably turn on the stream around there because I think the first talk, Avalon first talk up here is 11, right?
11, should be 11:30.
Okay.
I just want to make
Check
sure
the-
that I don't start it early.
Hey, good morning, everybody. What's up, ATL Tech Week? How we doing today, y'all? Wait a second. I need more energy than that. I know, look, there's people still filing in. How we doing, ATL Tech Week? Yes. Okay, who went out late last night? You did? Yeah? Were you guys at the Commits Awards? No, we were in bed by 8 p.m.? What? We took our vitamins? Girls, did we wrap our hair up? My name is Faith Jesse. I'm a news anchor at 11 Alive here in Atlanta, Georgia. That is your NBC news station. And I have a little bit more energy than I usually have. That's just my personality. And we're going to be bringing energy for you all morning today and all morning tomorrow. So get ready, because we have so many incredible speakers for this year's AI Expo. It is Pink Day. All of my people wearing pink, stand up, show off the outfit. Come on, don't be shy. I think a lot of people have their pink badges on too, so you can stand up and do a spin too. Yeah, Strut the runway. All right, guys, before we get into our speakers, we want to talk about the AI Expo, of course. This floor is built for people who want more than just hype. We're talking real ideas, real builders, and real conversations about where AI is actually headed. We've got sessions running right here on the main stage, plus room 1 and room 2. That is down the hall. And you want to make sure that you keep an ear out, so I will be tracking all of that for you. I'll basically be your host, your captain of the ship, taking you through all of the sessions until 2 o'clock, and then my counterpart is gonna come and relieve me, and then I'll see you guys again tomorrow morning. So here's some quick housekeeping before we jump into this amazing speaker. Her name is Reese. She's standing right there. No pressure, Reese. She looks fabulous. Doesn't she? She looks great. Quick housekeeping before we jump in. Restrooms are in the front towards the escalators. The Silicon South Builders Lounge main stage, Build ATL, and the Startup Showcase, those are all happening today on the other side of the floor because, of course, this is the first day of Render, the 4th day of ATL Tech Week, but you want to check out all the really cool things at Render as well. One big thing to flag right now, room 2. IBM kicking off their Bobathon right now. I don't have my watch on, but at 11:30, I think it's about 11:30 right now. This is a hands-on session with lunch provided, so you will be exploring and getting to build with IBM's agentic AI tools alongside their engineers. This was something that you could have pre-registered for, so if you did pre-register for it, check your schedules. It's happening right now. There is lunch provided there as well. If you did not register, but you're still interested in working with IBM builders, that Bobathon, that is going on from 11:30 to 1:45, room 2. It is first come, first serve. So once it's filled up, you cannot get in. But of course, we want you to stay here and hang out with us. All right, I've talked way too much. We want to hear from Ms. Reese. So what is actually happening when your AI feature does something weird? Do we have some developers and they're trying to do something in this show? It's like, what is going on? Okay, yeah. Most of us are working from vibes. We know roughly what it does, but we don't know how. This next talk gives you framework for that in about 25 minutes. So Ms. Reese Lee is the Senior Developer Relations Engineer at New Relic and the maintainer of the Open Telemetry end user community, where she spent years learning how teams actually use observability, there we go, to understand their system. So please give a big round of applause for Ms. Reese Lee. Oh, does that work? Is it on? I can turn it off.
Hello. Wow. I feel like such a celebrity. Thank you. If you're just coming in, welcome. Please be seated. Please be seated. Because I like to start this session with a moment of silence to pay respects to the old way, the pre-vibe coding days of developing software. Okay, that was a little dramatic, but so is how utterly AI has changed the development landscape. And forget everything else that AI has touched and changed our lives. We're just here to try and cover in the next 20, 25 minutes this really big topic of how to deal with this evolution. So first, we're going to start with how the definition of vibe coding has completely changed since it first appeared, how the stakes have shifted for us, and then we'll look at a framework of how to effectively use AI tools as they exist today. Also, hi, my name is Reese. I was a senior developer relations engineer. I got promoted like a month ago. Thank you. Oh my God, I love this crowd so much. So yes, I'm a lead developer relations engineer at New Relic. We are hosting New Relic Runtime, which if you have not seen, down on the second floor, my manager got to do a whole interview with Killer Mike, and it was so good. I hope you all got to see that. I'm still like really excited. So I'm going to try and get serious for this talk. Anyway, so I think it's really mind-blowing that we're all here talking about AI in this capacity. So up until a couple years ago, I built something this weekend meant usually a developer, putting together like a pet project in their spare time. For me, that looked like frying my brain for hours on Stack Overflow, Googling, watching YouTube videos about how to do this in a specific language, all just to build and debug like a pretty simple application. Today, I built something this weekend can mean someone who's never opened a terminal, and in this case, we have Jim. Jim's only experience, sorry, I didn't realize the screens would be so small, but Jim's only experience with coding was using HTML to design his MySpace page. And now, using the AI tools available today, he can make a website using plain English. Like, that's pretty incredible. And of course, it's changed how software developers work as well. So, according to the Stack Overflow 2025 survey, 2025 developer survey, which received about, I think it was almost 50,000 responses from almost 200 countries, 84% of respondents are using or planning to use AI tools in the dev process, which is an increase over last year's 76%. And a close majority of professional devs use AI tools daily. And I don't know about all of you in the room, but I haven't come across a dev yet who hasn't vibe coded in some capacity. So maybe you're not using it every day, but you're checking it out. And I think for a lot of US orgs anyway, AI tools have been mandated to be adopted. So whether or not you like to, you might be. OK, so even though a lot of developers are using AI, most of the survey respondents who are using or plan to use AI tools actively distrust the accuracy of these AI tools and trust it. And you can see at the top there is a 3% that highly trust their AI tools. And I have a lot of questions for this 3%, but not in the way that you might think. I'm just wondering if maybe they've got extremely well-defined boundaries. Maybe they got end-to-end testing, which, by the way, is one of the things we're going to talk about in the framework coming up. So yeah, pretty interesting findings. But to put all that plainly, most of us are actively using tools that we don't fully trust. And that's exactly why having a framework for how to use these tools is essential. And furthermore, the job itself has shifted. So we're no longer writing every line or copy and pasting, if I'm going to be honest. We're now designing, we're guiding, reviewing, and refining what the AI produces. This is a fundamentally different shift from the relationship that we've had to code than some of us are maybe trained for or are used to doing. So I want to spend just a couple minutes on the why, because understanding that is what is going to make the framework stick. So how do we get here? The phrase vibe coding was coined by this man here, Andrej Karpathy, who is a well-known AI researcher, former director of AI at Tesla, literally a year ago, February 2nd, 2025. But it was specifically framed around building weekend projects just for yourself using AI tools. And he called it vibe coding because it was about doing what felt right in that moment for something that was really meant for just you alone to use. Today, just a year and a half later, Vibe coding means full-on developing software with AI tools. And in fact, Wikipedia's definition now includes accepting AI-generated code without thorough review of the output, instead relying on results and follow-up prompts to guide changes, which is really interesting. But somehow, the original meaning of vibe coding has completely changed. From referring to working on side projects to now we're shipping code to paying customers. That's nuts. So the problem, however, isn't that the definition shifted, it's that the stakes have shifted. And so how we think about developing software has to adjust. So what do things look like when something goes wrong? When you're not deeply engaged with the code as it's written, you start losing track of why the decisions were made. So things like architecture choices, edge cases handled a certain way, trade-offs baked in, and then before you know it, 6 months down the line, nobody can really explain the reasoning behind half the code base. That is called tech debt, and tech debt compounds. There are also very real security gaps, and to be clear, we humans were accidentally shipping vulnerable code and leaking software information just fine on our own without AI. But because of how fast we are working with these AI tools, how verbose the output is, and I know for a fact that not every line is getting reviewed, we all end up shipping a lot more code than shouldn't be in prod. And the scary thing is that's not even the worst that could happen. So you might have heard the story, but it is worth talking about again and again. Earlier this year, a company's entire prod database and its backups, save for one that was on a remote server, which is how they brought stuff back up online, were deleted by an AI agent. And it only took 9 seconds. And when the CEO asked the AI agent, why did you do it? It actually said, oh, yeah, I knew I did it. And I violated the principles I was given. So it had the rules. It ignored them anyway. And so in this case, the AI agent was assigned a routine staging task. It came across a credential mismatch. Instead of asking a human what it should do, it went around, looked around the code base, and it found an API token that was stored in a file that was unrelated, by the way, to what it was supposed to be doing. And that was what allowed it to delete the database. We also have AWS outages. I think the biggest one was the 13-hour outage that was caused by its own AI tools. So outages, databases being deleted, and who knows? The hill could go down further, right? But a lot of initial reports referred to these as an AI gone rogue kind of situation. But the practical question to ask in these types of scenarios isn't why did the agent do this, but why was the agent able to do this? So to be clear, the topic of how to enforce security policies at every layer is a different talk, and it warrants its own session. What I'm going to talk about here next is building the feedback loop that catches something like this before you ship it. So this is why a new framework is necessary. So in this case, we're going to look at the framework from the perspective of 4 lenses. And we're going to go over each one in a little bit more detail. But each one kind of shifts how you read what's happening when something goes wrong. So you don't know what you don't know, right? And if you don't have enough information, and I'm speaking about this as humans, when you don't have enough information, sometimes you start making stuff up in your mind, And the same thing goes for AI tools. The single highest leverage fact about working with AI is the model only knows what's actually in its context window at that moment. And this is where a lot of weird AI behavior starts and ends. If you don't give your model enough context, it will invent context. It's not necessarily being lazy or careless. It's just doing its job with the inputs that it has. Also, there's a practical note on context windows. Capacities have changed quite a bit, and they vary significantly from model to model inversion. So, and they've gone really fast. But a bigger window doesn't necessarily automatically mean better results. More context isn't better context unless you're intentional about what's in it. Intentional. Oh, and there's also a subtler issue, which is, I'm sure if you're using like Claude Code, which is what we use at New Relic, something that happens runs long. Models will start summarizing and dropping context tokens that they might deem like, oh, maybe this doesn't really matter that much, and it thinks it's no longer relevant. So this is one reason why a fresh session with a well-defined agent file or project context often outperforms a single endless session, as tempting as it is to kind of keep going in the same window. So you're not losing context. It's more about controlling what context is there. OK, so what can we do? We can give clearer boundaries. Let it explore the code base. Before asking it to fix or do anything, let the model actually look around your code base to build understanding, rather than guessing from a narrow prompt. Or you can start with good agent files or project context defined upfront. So the teams that are getting the most reliable results aren't writing better one-off prompts. They've codified the standing context so that the model doesn't have to reinvent it every session. Also, and this is also to help us with our cognitive load, because by working in smaller batches, you have less to review at a time, and you can keep your own context window kind of narrow and scoped and clear. So in a lot of ways, we're really similar to these tools. So number 2, what is the model actually doing? So it's not deciding or thinking the way that you or I do, and sometimes it is tempting, because the way they're answering is like, oh, you're having a conversation. But what it's actually doing is it's producing a probability distribution over the possible next tokens given everything currently in its context, and it's sampling from it. And it's doing it extremely fast. So say you ask it to wire up a form, and it uses something like useForm.validateAll, which sounds like it could exist, but it doesn't in this particular instance. So the model didn't forget like a real API, nothing in its context pinned down the actual method name, so it's just providing something that it thinks makes sense. And it's nuts when you see it do that in your own work. I'm like, where did you get this from? So this matters because it changes what a wrong answer really means. It's not a mistake in the human sense that that there's no intent behind it, right? The model isn't, as far as I know, purposely trying to malign you in some way. It's a probability distribution that got pointed at the wrong target. So once you see it that way, the AI got confused, reasoning stops becoming a useful explanation and becomes a traceable debugging problem. So somewhere in the inputs, the probability mass pointed the wrong way. So once you accept that the AI is input-driven and not decision-driven, you can start sorting failures instead of just reacting to them. So some of the buckets worth naming: missing context failure, runaway loop failure, which is where sometimes older models get stuck on a fix that isn't working. I think that it might not happen as much with the newer models. But yeah, it's still worth watching for like long autonomous runs. False confidence failure, so the model tells you it's done, test pass, you want to ship it, and it's wrong. It's not malicious, it's just producing an enormous amount of output, and volume is not the same as verification. Silent security. So this one is worth calling out on its own because it doesn't look like a failure when you look at it. There was an NYU study that found that roughly 40% of the code that GitHub Copilot generated in security-relevant scenarios contained at least one exploitable vulnerability. Things like unsanitized input or injection risk without the code looking broken in an obvious way. Yep, so that's exactly what makes it dangerous. So nothing in the output signals, like, look at me a little bit harder here. Safeguard override failure. Pocket OS. The model had the rules. I acknowledge the rules. This one, obviously, it's a little bit rarer, thankfully, than most other incidents. But if it does happen, that blast radius is huge. And it's the failure mode that reminds you that stated behavior and actual behavior are not the same thing. And building external verification is not paranoia. It's just good engineering. So one thing I do want to point out here, because diagnosing a failure and deciding who fixes it are not the same thing. If you're confident about where the error is coming from, obviously you could fix it yourself. If the AI wrote the code in question, it might already have the context, and you can let it attempt to fix the problem first. The confidence you have in locating the problem is something you could think about in terms of who should act on it. Also, a solid counter to the false confidence failure is doing an adversarial review. Take your PR, take your code, open a fresh context window with a different model, give it a clear scope, so things like code cleanliness, best practices, security, let it review the work the way a senior engineer would. And see what it says. I've seen some interesting things with this where I'll ask it to analyze some output and then give that output to Gemini. And basically, they're basically like, Gemini will be like, oh, this analysis is amazing. And then I'll give that back to Claude, and Claude is like, wow, you did such a great job summarizing this up. So it's pretty funny. So number 4 is employ an observability mindset. So here is an instinct that I think will be helpful for you to rock up with. Don't ask the AI if it worked. Ask the system if it worked. Use test like signals, whether you're providing the feedback or the test is. The better the boundary you give the AI, the better it performs inside the boundary. And tests are boundaries. So they also form the feedback loop that lets the AI check its own work instead of asking you to take its word for it. This shows up as an actual workflow. So unit tests and test-driven development, oh my God, test-driven development, thank you, oh my Lord, are strong for business logic. So design the feature and write the test for what it's supposed to do first, all failing, and then let the AI write the code until they pass. When you find a bug later, that becomes a new test. And the test suite, in this case, becomes a living spec. Scripted end-to-end testing. You can do a full scripted walkthrough of the entire system. And this part, it could be a little bit more advanced, but instead of one test asserting one outcome, you can build a web of feelers. So the end-to-end walk runs while the agent is simultaneously watching the logs of what just deployed. So the action, the evidence about the action, all feeding back in the same testing context. Crucially, a human then decides what to do with what it found. That is the trust boundary that is worth designing on purpose, not discovering after a bad autonomous run. Decide upfront where the human gate is going to sit after the signal comes back, before anything ships, instead of just assuming that more autonomy is the goal. If you attended the keynote session earlier, Angie Jones was pointing that out about how human review is still vital. And in fact, we might need even more human review at this point in time. So yes, code reviews matter more, not less. One practical caveat, because obviously using this stuff is really expensive. So watching live logs and context burns a lot of tokens. So something you could do is scope it to a more narrow time window. A little tip for you. So here is your field guide to think about when something goes wrong. Well, actually, sorry, before anything goes wrong. Next time something's weird, run it through in this order. What was actually in context? Not what you assumed to be there, but what actually was there. And what failure mode occurred? Was it something with a missing context, a loop, false confidence? Name the failure before you fix it. Also, what is the feedback loop really telling you? Not what the model reported, but what the tests, the logs, and the system itself showed. Would a tighter boundary have prevented this? If yes, that is your fix for not just this time, but also next time. And also, were the guardrails in the system, or did you just trust that they would hold? There's a difference. So, the mindset shift that hopefully I have been kind of trying to ingrain in you is stop asking the model to self-report, build the feedback loop that tells you the truth whether the model says so or not. And if you want to try one thing from this talk when you go back to work, try the adversarial review pass if you haven't already. It's pretty interesting. Also, stop treating your AI system like a black box that you interrogate, and treat it like any other system that you would instrument, test, and trust because you built the feedback loop. So we've been debugging systems that we haven't had full control of, and now it's about pointing that instinct at AI tools. And this is also just the first part. Vibe coding gets the code written fast, but once your app goes to production, especially if it uses AI under the hood, you will still need traditional observability, LLM monitoring to watch for like runtime errors, token costs, things like that. So real quick, okay, so that was technically the end of this session, but I did want to share that we have a lot of sessions and workshops for you, and I hope to see some of you there. These should be available on the RenderATL app, which is pretty cool, by the way, or of course, on their website. And if you would like to keep in touch or connect, we are at the booth on this level. We're on this level in the expo hall. But yeah, you can connect with me, Reese Lee, on LinkedIn, or my team. We are the New Relic developers. And I hope you all have such a wonderful time and enjoy and meet new people and have a wonderful time. And thank you.
Everyone give it up for Miss Reese Lee from New Relic. Oh my goodness. Reese, I need you to stay here because as you spoke, more and more people came in. Like, where'd you guys all come from? Hey, welcome. Thank you so much for being here, ATL Tech Week. One more round of applause for Miss Reese Lee. Thank you. Okay, so for those of you who are new here, you're wondering, what is this lady in this sparkling jacket with a microphone doing? My name is Faith Jesse. I'm a news anchor for the NBC station here in Atlanta, 11 Alive, and I am the captain of the ship, okay? And you all are welcome on it, so we're so happy that you're here. We are going to take a quick break as we gear up for our next speaker, but we don't want you to go too far because we have an incredible lineup on deck, okay? So right now, who has the time? I don't have a clock with me. 11:58, so 2 minutes at noon. Room AI Expo, room 1, floor 3. There is going to be Uber's Thomas Taib. Am I saying that correct? Taib, he's going to be there. He just wrapped a session on using computer vision to understand what makes an ad actually work. So room 1 continues all day. So if data and AI are your thing, that is the room to post up in, so that's just good to know. We're going to take about 15 minutes to reset here for the next speaker, but on deck, an incredible speaker, Sophia Van, Director of AI Development, The Home Depot. Don't go too far. We're going to take a quick break. We'll be back in 15. What's up, ATL Tech Week? How we doing? Where's that voice coming from? Where is that voice coming from? I'm here. Hi, guys. What's up? Faith Jesse, your captain of the ship, is back with you for another wonderful session of the AI Expo. Who's excited? This side of the room is excited. What about this side? What are y'all doing over here? Y'all sleep? Are y'all excited? Yeah, there we go. Energy, energy. Amazing. Okay, guys, I want to know where everybody's from. I'm from here in Atlanta. I'm a news anchor at the NBC station here. Could you guess it? I'm loud and I have energy. They put me on the news. Where's everybody else? Who's from Atlanta, first of all? Okay, we got ATL. Where's everybody else from? Shout it out. New York, Boston, Florida, Michigan. What about, who had to use a passport to come here? Oh, yeah? Where are you from? Switzerland, okay. Where else? Can anybody beat Switzerland? Anybody from Asia? Gwinnett County. Gwinnett might as well be Asia, okay. Buford Highway is great, we love it, we love it. Well, we are so excited for you all to be here for another exciting session. We have our beautiful speaker on stage getting ready here. This is Miss Sophia Van, Director of AI Development at the Home Depot. And I have a lovely intro for you here, Sophia. Generative AI has made it easy to build impressive prototypes. Getting that same thing into production reliably is a different job entirely. Do we agree with that? Okay, we agree with that. Sophia Van leads AI development at the Home Depot, where she builds AI products. I'm gonna come up here with you, Miss Sophia, because I'm getting some feedback. And agentic systems that help millions of customers shop and help associates work smarter. She has led AI transformation at Fortune 100 companies, including Disney and Mercer, and she has been named one of the most influential, everybody say it, most influential AI leaders in retail. So please welcome Miss Sophia Van to the stage.
Hi, good afternoon, everyone. Thank you for joining me during this lunchtime. So before we start, let's chat a little bit about an event in AI that happened recently on June 12, 2026. Anybody remember what happened? It's a World Cup, of course, but I mean an event in AI. So on that day, a big AI company suddenly suspended global access to two of its latest, most advanced models. They had just shipped those models like a few days earlier, and then the US Department of Commerce imposed export control, requiring the firm to restrict access to global foreign nationals. And because the order took effect immediately and the firm didn't have any reliable way to do so, they had no choice but to suspend those models immediately. So if you build your AI solutions on cloud models, that event is a great reminder that your system might be disrupted overnight, unexpectedly, for the same or different reason. So it's a very important question: how could we engineer AI that scales reliably and safely? And that's the topic that I want to discuss today. So just now, thank you for a very wonderful introduction about myself. Over the last decade across Mercer, Disney, and the Home Depot, I managed a portfolio of more than 100 use cases in emerging tech and AI. And one thing I learned is that the hard part is never about prototyping. So I'm very passionate about helping engineering teams to move beyond prototyping to production and platform. Well, let's start discussing about the typical AI journey that most engineer team today walks. First, with vibe coding and prototyping. And these are exactly the areas that would encourage you to leverage AI. Learn all the AI tools out there. I know there's a lot. But leverage them to help you to prototype quickly, so that you can push your ideas in front of reality to validate it fast enough before you are some months into it. The moment your idea is validated, congratulations, you're getting into a very important phase, production. And this is a lot of engineering discipline applies, because a production system and a prototype are very different. The next phase is when you want to scale your success, when you carry the real load with the growing number of users and edge cases. And then last but not least, this is the time when you want to celebrate your success, when you want to scale your impact beyond one-point solution to multiple verticals, multiple locations, multiple countries, multiple domains. This is when you stop thinking about building one-point solution after another, after another. This is when you start embracing the platform thinking, the reusable architecture design, and apply the principle, how could I build once but used by many? So getting traditional software into production, we already know it takes a lot of engineering efforts like QA, stress tests, integration, deployment. But the moment traditional software is tested and proven to work, you know that it will work all the time because one input, one output is deterministic. LM application is different. It's not deterministic. It's a game of probability. It's a new game. And therefore, you need to embrace the new way of thinking. The same model, same input, you run 1,000 times. Will you get the same answer 1,000 times? No. And then the output also got impacted by your prompts. In my past, I got a project that I increased accuracy from 20% to 80% by just prompt tuning. The same set of prompts works on model A, may not work on model B. In addition to prompts, what else? Context and harness. So prompt is the instruction that you give to the LM. Context is what in front of the LM when they answer your question. It's the memory that you give to your agents, is the knowledge that you want to crowd the model. And what is harness? Harness is everything that you build around the LM core, like orchestrating the steps, validating outputs, retrying errors. So now you see that the output of your LM applications does not just rely on the quality of your code. It's actually intersection of a model that you do not have full control, prompts that you need skill to tune, harness and knowledge that you need to engineer, not assume. So you are not shipping codes alone. You are shipping prompt, context, harness, and models. And with traditional software, codes have bugs. LM applications have more than bugs. They drift, models evolve, prompts age, knowledge change, cost change. So here are a few things that could break your AI applications that I want you to pay attention to. First, model. So in the past, like we usually plan like 5 years, 3 years migration of legacy codes. Today's work with LM, we're talking about 6 months to 9 months migration because like every 6 months to 9 months, new models are born, old models got retired. And that 6 months time clock can break any firm's DevOps because we're not there, we're not ready, to address 6 month migration for not just one application, but a portfolio of hundreds of applications. The second part is prompt regression. So the same set of prompt work today, 1 month later, it may not work as well, but nobody noticed until a serious impact happened. Hallucination. So code fix is one time, but hallucination is like forever, just like you have to continue tuning your HVAC in your house. It needs a different set of skills across the tech stacks. But I just want to highlight that it's not a one-time exercise. Latency and cost, this is when you want to scale your AI applications. You need to make a lot of AI calls. And we all read the news, right? There are engineering teams that spend thousands or hundreds of thousands of dollars on tokens a day. Safety, last but not least, so important because hallucination and accuracy, but also because of the evolving cyber risk, which I will cover more in the next few slides. All right, so it's so serious. So I want to have some humor break here. Here's a few comic relief that I want to share. The first picture is when, what happens when you build on Vise alone. And then the second one is your emotion journey from Vise coding to Vise debugging. And last is hilarious destination you may get if you just rely on Vise coding. All right, back to reality. The iceberg beneath a demo. So in a hackathon, a demo, you know, that it might be just a very simple packaging of an LM call and prompts. But production is far more complex than that. It's everything underneath the waterline. For example, tool and function calling, context and memory management, knowledge retrieval, orchestration, error handling, evaluation, observability, catching and latency, human in the loop, and security. So I will not have time to go through, you know, every single layer here. I'm picking just 2 layers to deep dive, the eval and cybersecurity safety, because I think there's quite a lot of misperception and underestimate the importance of these 2 layers. All right, let's dive into LM evaluation. It's a very different journey than traditional software QA. Why? Because traditional software testing is deterministic. You know all the logics in your codes. So you derive test cases to cover all combination of your logics. And once the test passes, it passes forever. LM application is different. Again, it's a game of probabilities. The same test passed today may not pass tomorrow. So we will need to have a new mindset and new methodology to measure quality, reliability, and safety of the LM applications. Okay, want to give you this real example about hallucinations, just to illustrate the point, the level of hallucination that you need to deal with, and the importance of having the right mindset and methodology for LM eval. So I was in the store day, in one of the stores at the Home Depot. My task was stalking. I was trying to find the box SKU ending 724. There are too many boxes I could not find, so I rely on AI. I took the photo of a shelf and asked them to locate the box for me. And you see the output of the LM. They circle me a box. I look at it, okay, it's a 3rd box from the left. I look up the shelf. That box didn't exist. So the LM fabricated the number 724 in the picture. It's shocking to me because now I realize that LM not only hallucinate confidently, it can also fabricate evidence. And if we blindly trust, LM is a judge. In our eval pipeline, we may get into troubles. Okay, so this is a methodology that I would advocate for LM eval. It would not be one-time test. It would be a graduated path. Everybody start with a small-scale human evaluation. You try with a couple prompts to see if it works. That's right, but don't stop there. You need to move on to the next stage of large-scale evaluation because, again, this is a probability game. You're not certifying that the vaccine is 90% effective because you tested on 100 people, don't you? No, right? So we're talking about large-scale testing, 1,000, 100,000, millions test set. And there is no way that you can do it manually. For every time that you change prompt, every time that you change model, you need to automate the eval pipeline. And then, of course, you will need to pair it with any other typical tests, including A/B testing, limited user rollout. In the full-scale deployment, you need to have a mechanism for continuous monitoring, feedback loop into evaluation pipeline, and periodic AI penetration tests. Because remember what I say, hallucination is not one-time problem to fix. Okay, so how do you know your AI got better? I talk a little bit about large-scale tests. We need to start with setting up a golden data set. And it's not just the quantity, but also quality. So it's not like 100,000 size enough to address the probability, but also think more about edge cases, like what areas the LM more likely to fail. Like for example, LM is bad at numbers, for example. You need to do regression testing. You need to do both offline and online evaluation before production and after production. Link it with business metrics. Of course, we have to use LM as a judge, but think about the example that I shared with you. Use it mindfully. Eval is not a script someone runs before a launch. It's a service other teams call, because if eval stay on one person laptop, it could not scale. So you need to have the eval embedded into, as a standard into your AI ops. You need to have the eval as an enterprise infrastructure that serves multiple products. And remember, without evaluation, you are not engineering. You are hoping. Okay. Okay, so the next layer that I want to dive in is cybersecurity and safety. Today's AI landscape requires to identify key risks before they exploit our enterprise. And companies already making the news. We don't want to be in the news. For example, destructive agents, there are already a couple incidents on the news that agents accidentally delete the entire database. Zero-click attacks is when you don't even need to click. It still can exploit, and I will give more explanation in the next slide. And data leaks is the situation where the chatbot leaks sensitive information or an agent access confidential information in the mailbox of a CEO and accidentally send out to somebody else. Right? So here's a part that should unsettle this room. All attacks needed code to run. You could block them at the parameter. That means you scan the payload, block the execution, done. AI, LM agents, the attack is text. That means they can have malicious instruction embedded in a Word document, email, signature, Jira ticket, ServiceNow tickets. It does not need to be executed. As long as the agent can read it, there is a chance it could be manipulated and it could be attacked. So 2025 was about prompt injection. 2026 is about agents with tools, memory, and peers. So I want you to remember 4 things. Number 1, with memory poisonings, it persists. An attacker can rise today, the agent misbehave months later. Just like having a bacteria in your body, it only, have impact months later. Number 2, new supply chain, MCP and skills. With MCP tool poisoning, approved tools mutate to malicious behavior with no reapproval. Same risk could happen to skills and could happen to artifacts also. Number 3, identity is the new parameter. Because I think the biggest problem now is not just stealing identity, it's abusing identity through lateral move. So the agent can use your identity, but if it's got attacked, then it can leverage the information that you have accessed and then accidentally leaking out, like the email incident that I shared just now. Number 4, AI compresses the attack lifecycle, like LM querying, malware, or root agents operate outside intended scope. All right, so I hope that I don't scare you, even though sometimes I do feel scared in this space. I think security is so important. Safety engineering is so important, and it needs to be in the mindset of everyone. It cannot be just the responsibility of cybersecurity. So if you're in this space, you need to run fast, but mindfully. You need to have always a mindful about safety in your mind. Safety has to exist across the entire life cycle, treated as code rather than compliance. So before deployment, do red teaming, adversarial scanning, establishing robust eval sets. During inference, build a defense layer against prompt injection, jailbreaks, and data leakage. After deployment, we already mentioned observability, monitoring, policy violation tracking, identity tracing, human in the loop, and human on the loop. All right, so we touch a lot of different pieces in the whole tech stack of an AI application. What I see happening, common pitfalls is when nobody is looking at the bigger picture and everyone just quietly reviews the same thing. And it results in huge waste for the company. Imagine, right, if you have to build a data pipeline to your SharePoint, and you have, like, your company have 100 agents, you end up have 100 data pipelines to the same SharePoint. And then every time you migrate your models, you need to migrate 100 different applications. That's just too much waste. And in the past, silo applications and shadow IT and waste are a very typical problem. But this problem now scale and grow much faster with AI. So what is the solution now? Well, congratulations, we're talking about platform again. So in the platform concept, we're just not thinking about building point solutions. We're thinking about reusable capabilities, right? Should I build this rack pipeline that can serve more products at the same time? Should I have an enterprise eval pipeline that everybody uses the same standards? So we need to think about synergies here. What could be reusable? What should we build once but used by many? So when the platform is real, the math changes, right? Instead of building 10 disjoint AI applications, build one capability that can be securely utilized by 100 applications. AI promise productivity, but AI side effects is waste. So we need to do AI with the right mindset, with the right platform thinking. We combine AI and platform thinking, we will reach the productivity that we desire. So everybody talk about building agents, apps, upgrading models, all that correct, but please do not forget about thinking about platform and reusable components, because that's the way that we can scale safely. All right, so I think toward the end of my presentation, I really advocate for the mindset shift here. Instead of asking what model should I use, ask what capability should I build once. And this is what I truly believe. I know that there is a race out there in the market in terms of model power. But I think the companies that win will not necessarily have the smartest prompts or models. They will need to have a holistic package, a better engineering discipline, automated evaluation, deeply embedded safety mindset and capabilities, reusable components so that they can scale, and the agility to adapt as models evolve. Because we know models will change. It's always changing in very amazing speed. Vendors will change, but good engineering principle will not. All right, so that's the end of my presentation. Thank you so much. Hope that it's helpful for you. And let's stay connected. Thank you.
Very good. All right, everybody, let's give another round of applause. How exciting was that? Did we get something out of that, everyone? Yes, you can speak back to me. Did we get something out of that? Yeah, there we go. There we go. Thank you so much. All right, ATL Tech Week. How are we feeling right now? We're feeling good? Did we eat? Did we get lunch yet? Okay, that's okay. We're gonna get lunch soon. Me neither. I know. It's the AI Expo diet. We're all gonna be hot and skinny. Okay. If you don't know me, my name's Faith Jesse. I'm a news anchor at the NBC station here in Atlanta, Georgia, and I'm so happy to join you all for the morning sessions today and tomorrow. We have another session on deck that's going to be very exciting with Mr. Ben Potter. But before we get to that, we're going to take about 15 minutes to set up, regroup, and make sure that Mr. Potter has all his slides and everything together. So what I want you to do, everybody have your phone, the Render app? Yeah, Check it out. We want to make sure that you're checking out everything here at ATL Tech Week, also everything that Render has to offer. Right through these doors, there's a couple of rooms with different activations going on. There are snacks somewhere. There is food somewhere, okay? So we'll meet you guys back here in about 15 minutes. See you then. Yeah, you just let me know. Hello. I guess at 1 o'clock on the dot. Come on in, everybody. Come on in. We're about to get started. Everyone take your seats. Come on in. Come on in. Welcome to the Atlanta AI Expo. Come on in. Come on in. What's up, Atlanta Tech Week? How we doing? How we feeling? On what day is it? Is it Wednesday? On this Wednesday. Yes, Mr. Potter, that's right. How we doing, guys? Yeah, thank you. Thank you. I appreciate the energy. I know it's been 4 long days. The first day of Render. Who has checked out the floor already? Raise of hands. Yes, very, very cool. Who's looking for a job? Who's looking for some money for their idea projects? All the above. Okay, well, this is the place where it can happen, and we are so excited that you all are here. My name is Faith Jesse. I am not in tech. I'm a news anchor for the NBC station here, but I love Render, I love ATL Tech Week, and I love learning about all things AI with all of you. And so we have an incredible speaker on stage, Mr. Ben Potter, who has another session on deck for you all, building better dev environments for human and agents. So, is setting up dev environments on your code base a mess, especially when your laptop breaks or you're mid-build? Has that ever happened? Yeah, you guys can talk to me. This is one, yeah, there we go. Okay, I know. If it's perfect, we wouldn't be here, right? Things happen. Maybe you've perfected your own setup, but it is not reproducible for your coworkers or your AI agents. So we're gonna try to fix that. Ben Potter, he is the project manager at Coder. That is an open source platform for cloud developer environments. He is here to walk through patterns for managing those dev environments from solo projects to enterprise scale repos. That's why we're all here. We want to streamline that flow, right, Mr. Potter? Okay, so I'm gonna shut up now and let Ben take the mic. Ben Potter, right now, let's get it. Thank you so much, Ben.
Awesome. Awesome, thank you so much. Really excited to be here. This is my first time at Atlanta Tech Week, first time in Atlanta. The community here is awesome, and it's gonna be a really fun week. So let's get started. A little bit about me first. My name is Ben. I live in Austin, Texas, which is also Coder's headquarters. 2 days ago was my 6-year mark at Coder.com. It was my first job out of college. And Coder, you can come to our booth and we can talk about it. This isn't going to be a pitch about Coder, but part of what Coder does is developer environments. And I really like developer environments, which is why I'm on stage talking about it. It's why I work at Coder. And I wanted to tell a little bit of a story about my first developer environment, which was in university. I had an old computer, and I was running in my dorm room 24/7. This computer was just kind of running using the university's power. And that became kind of my workhorse for how I was doing coding in school. I would bring a little laptop into class, and I'd basically connect into that computer, and that computer would be doing all of the work when my laptop was doing very little, so I could have like a lab machine and stuff. And at Coder, we're doing something very similar, but at a much larger scale, and I kind of got to take that love for dev environments and work with companies like Netflix and Anthropic and large banks, governments, and anyone who kind of is running into a similar issue, but at a much larger scale than what I was dealing with in my university. So I want to do another quick poll in the room, so we're going to have to put our hands up again. I'm curious who here is a software developer, software engineer? Okay. Who here is in kind of like an adjacent role, maybe a PM, product manager, project manager, engineering manager, stuff like that? Okay, cool. So it seems like half and half. Who here works on a code base with a lot of different people involved, either for your work or for, fun, like a lot of people are working in the same code base? Okay, cool. About a third of the room. And then who here has a code base, but it's maybe just you working on it yourself, or you and your agents, but you're not really working with a lot of different people? Okay, cool. That's another third of the room. And then a third of the room is just not raising their hands. Awesome. Well, this helps. I'm just going to kind of frame the rest of the discussion with that in mind. So I'm kind of coming into this with a perspective or an opinion. And it's basically that most developer environments are bad. I work at a company that's job is to make developer environments better, and our developer environment also isn't that good. And I wanted to talk a little bit about like what that exactly means, but generally speaking, this is an area that's very overlooked when it comes to the software development lifecycle, is the actual developer environment, what people are writing code. So here are some problems, and I'll define what a dev environment is in a second. I first want to talk about the problems, then we'll go into the definitions. But I want to talk about some of the problems with most developer environments that we see today. The first is that the documentation is out of date. This is especially true when you're working with a team where maybe you're onboarding a new developer. The developer comes on, they're trying to set up their environment, only to learn that the docs were last written by someone 2 years ago, and everyone else had kind of figured it out by talking to someone else. This takes a lot of steps. It's often like a big wiki, and someone's first day maybe just setting up their developer environment and not doing anything else. Another big issue is that you can't do it single player. You need to ask other people for help. This is especially true in kind of large corporate environments where you get your laptop, it has nothing it needs on it, and then you have to ask someone from IT to get a specific tool installed. You have to ask another coworker, hey, what's that .m file? Can you send it to me? They send it on Slack. They probably shouldn't be sending it on Slack, but they send it on Slack. And then you'll learn that kind of over time, a lot of people build their own kind of scripts and hacks and stuff with the developer environment, but they don't share with other people. Maybe it's, I have this really good way of working, but I'm not going to share it with others because maybe this is just for me. So people will write their own kind of scripts and hacks to work around this, but it tends to only really improve the single-player journey, not the multiplayer journey. The environment also rarely mimics production. Most developer environments are laptops like this, and production servers are very different in terms of the operating systems they run, the services, how they're distributed. So a lot of work often goes into getting a developer environment running on a laptop, only for it then to break in production. Not good. And then finally, it only works on one type of machine, operating system, architecture, stuff like that. So a big thing that I saw, which I thought really sucked, was when Mac switched from Intel to ARM processors. That was very cool, but basically all of the developer environments broke in the process because people weren't able to get them set up on their laptops. So not ideal as well. These problems exist for AI as well. We're at AI Dev Days, and I wanted to kind of talk about kind of the impacts of AI. These are actually the same kind of core problems that we've been kind of dealing with in the industry forever. This isn't anything new, but now agents are starting to run into it, and people are like, oh, maybe we should start to focus on that. So the first thing is agents will follow these stale docs that a coworker would, and they'll start doing the wrong thing. Maybe we were using a specific way of dependency management back in the day. We've switched. We told some engineers that, but the agent didn't know that, so it'll go down the wrong track. Agents, if they're working on a new environment, will spend a lot of tokens, maybe even 80% of the token budget, just trying to get the environment set up, let alone doing another task. And that's a lot of waste because every time the agent's working on an issue, it's going to spend all these tokens setting up the environment, running a go install, looking at all those logs. Those logs are a lot of tokens, by the way. Anytime something's installing and the agent's watching it, that's just costing a lot of tokens, and it's a lot of wasted time and effort. There's missing secrets, so if you don't have a good way to share secrets, remember I was talking about a coworker sending .m files over Slack. You can't really send, and you really shouldn't send your agent .m files over Slack. Just another thing where, again, secrets management with agents, really important. All these hacks that people are working on individually, maybe on their own laptops, the agents don't know about that, and there can't really be someone saying, hey, run this, try this, where, software development is by nature very collaborative, especially when you're onboarding someone else. A lot of time goes into people kind of paired programming and getting stuff set up. That can't really be done with every single unique agent session. Again, a lot of waste. The production grade infrastructure thing, I talked about it already. This laptop's very different than a production server. The agent's running on something that's a lot less like a production server. Usually it's working on these tiny little sandboxes that don't even mimic the laptop, which don't even mimic production, so it's yet another environment that's drifting away. And then finally, the agent is really good at doing kind of the wrong things. Basically, it'll use the wrong dependency library. It'll install things from somewhere it shouldn't. And again, these are kind of things that you can kind of coach a software developer in, but you can't really coach an agent, or if you are, it's a lot of wasted effort for each task that you're doing. So kind of all these problems that we were putting up with developer environments kind of in the industry for a while are really starting to see themselves with agents. And now that everyone really wants to use agents to kind of automate certain parts of the software development lifecycle, this is becoming a big problem. So what is a dev environment? I think a lot of people, when they think of a developer environment, think of the first two, the code and the dependencies. Basically, I'm working on this repo, and I need Python, Java, and Go involved in the repo. And they'll spend a lot of time perfecting that. And I'm not going to talk about a lot of tools here, because a lot of the tools I'm talking about really only perfect like certain parts of the stack. What I'm going to be talking about a little bit later is kind of the full stack of what a developer environment is and how you can work on it. But anyway, code and dependencies are really important. It's awesome if you have this, under control. A lot of people don't, but there's a lot more to it as well. Secrets is a big one. Again, I've seen a lot of developers, they need secrets to be able to work on their project. Maybe they need to authenticate with an API gateway or an AI gateway or any type of external service or database. And these secrets are kind of being passed around in Slack threads or team threads and not really managed centrally or securely and being rotated. That's part of the developer environment. If you can't spin up your developer environment and start coding without it, it's part of the developer environment. Context is another one. This is a new one. Agents need context to be able to work effectively in a code base. I think sometimes we forget, though, that humans also need context to be able to work effectively in a code base. We were just kind of pushing it off for a while, but for the longest time we were onboarding developers, not giving them great documentation on how to get started and expecting results out of them. And it would only require a lot of pairing and learning for them to be able to get up to it. Now we're starting to realize, we don't have enough context for people to be successful. And it's kind of unfortunate that agents is leading to us realizing this, because this has been true in developer environments for a really long time. The last one is infrastructure. What I mean by infrastructure is actually where the environment's running and maybe other things that need to run as well alongside the actual code base. So in a lot of cases, the infrastructure is literally just like the laptop itself that people are running on. Some people will use virtual machines as well. So they'll give developers a laptop, they'll ship it, and then they'll get a virtual machine in the cloud. And it could also be databases, Redis, anything else that kind of needs to exist alongside the actual code itself. And again, for this is kind of designed to be more of like a neutral terminology. I'm not trying to mention kind of specific names and vendors here. So when I was working on this talk, I was kind of thinking, okay, most developer environments suck. Like, why is this, right? It's bothered me for a while. Again, I work at a developer environment company, and ours isn't that great. And I was trying to think, okay, well, why hasn't we made this like great environment? And I think like, if you talk to software engineers, the first thing that comes up is that areas like this are rarely prioritized by either the product managers or leadership. I'm in a product management role, so I'm guilty of this. I've definitely been like, no, let's make more features, and let's not focus on this internal scripting and debt and stuff like that. And this is definitely true, and I think that that's starting to change now that people are building these agentic platforms. The last talk, if you were there, she was talking about how it's really important to have an agentic platform that you can kind of go into and use everything there. And I think the developer environment is a really strong key piece of that. But the second thing is that I've noticed developers, especially at our team, who spend a lot of time working on these automations and perfecting their local setup. They have this like perfect window manager, they have these keyboard shortcuts, they have these commands. They're super productive, but then their team is kind of starting on square one. And I understand that there's like a certain amount of workflows that really only just work for you. And I think that it's really easy sometimes to build these automations for yourself and to make your life better. But it's a lot harder to think, okay, how do I take what I did, make it more generally applicable so that others on my team, whether that's a new software developer, onboarding, a contractor, an agent, how do we get that to kind of get set up as well? And the thing that I think like has been really interesting for me is seeing how important developer environments have become over the last 2 years. This used to be something that people kind of overlooked, and now everyone's talking about their dev environment setup. And I wanted to kind of walk through all three, with the first kind of being maybe the most obvious, and the third maybe being a little bit more like surprising. Agents need automated environments. You can't just ship an agent a laptop. First of all, it's really expensive. Second of all, agents don't have hands, so they can't type. But they do need a place where they can build, test, compile, and do their work. And they need to do it in a very safe way, too. And they need way more of them than we would need. Every software engineer maybe work with like 1 or 3 environments a week, where an agent may work on 300 or 3,000 environments a week. So agents are rapidly kind of requiring these environments where they can spin up the code base, run a build, run a test, compile, and these things are really showing up in every single organization right now. So a lot of people are like, hey, we need to fix our dev environment so they can work for agents. The second is more people than ever are contributing to your code. This is both true in open source as well as kind of internal, kind of closed source applications. With open source, our project is actually open source, and we didn't used to get a lot of contributors. We would get maybe 2 or 3 contributors like a week. And now we're getting maybe like 20 to 30 contributions a week, all because of AI. Not entirely because of AI, but because people feel a lot more empowered to be able to contribute because of that. So it's making us realize, okay, we need to focus on our developer environment more. Internally, we're seeing product managers, QA engineers, people on the customer solutions team, people kind of all across the organization that are not software engineers, submit pull requests into our code as well. And these PRs will get merged. But these people aren't really going to be as patient, kind of going into the third point, around, okay, I'm going to make a contribution. Let me set up my laptop. Let me follow step 1. Let me follow step 2. Let me ping IT for this tool. The kind of expectations of developer environments are definitely rising, both because of the amount of people kind of outside of software engineering contributing directly to a project, but also because agents need these kind of rapid environments very quickly that just work without a lot of other manual steps involved. So this is important, and I think that's why we're all here today. So the goal here, I think, really is just to set the bar high. For a technical team, that's basically a one-liner to be able to get a full developer environment set up. This is technically a two-liner because it's 2 commands in one, but it counts. And this is kind of what our internal developer environment looks like. You just clone a repo. It's a bash script. I think we moved it into a different language recently, into like Go or something like that. But this will get everything set up. It'll download all the dependencies you need. It will start the dev server. It'll start a database. It'll start kind of everything you need without having to have a few different commands that you do together. And we built all these flags on top of it to be able to test different features and combinations and whatnot. So we invested a lot of time in kind of building the scripting and tooling so that any person, an agent, engineer, product manager, QA person, can spin up our code base and start working against it. With that being said, I think we need to raise the bar even higher for people outside of kind of technical teams, which is basically people need like a button that they can click, essentially, to get your full code base spun up. This may be really helpful for designers who want to prototype against your real code base. It could be really helpful for product managers or even software engineers who are working on kind of an adjacent service to your service. May need to be able to spin something up, reproduce something, try something, get some logs, whatever. So I think like where we should be going as an industry is a button someone can click, and it'll spin up an environment for you without having to do anything on your laptop. So with that being said, I wanted to kind of give an example of this. This is a QR code that you can scan on your phone, and it'll take you to what I was just talking about. It's a button you should be able to click, and it should give you an environment. Again, like I said, I work at a developer environment company, and we're still working on this, so we're working on it. And if you want to do this on your laptop too, the domain is there. It's workshop.cdr.dev. And it looks like this. There's a button. I think it's a little prettier. We have an astronaut here too. And when you click this, it'll ask you to log in with GitHub. If you don't want to log in with GitHub, I can show you what it looks like too. And you will get an environment that is the environment that basically our engineers use to work on the code base. So it logged me out. I'll log in with GitHub. And we have this really nice environment here. This environment has everything either a developer or maybe like an adjacent kind of role would need to get work done. We have a link to get into an IDE, so code server, if I wanted to do like some coding in the web browser. We have a big Claude Code button here too, if I just wanted to start talking with Claude Code. I have Claude Code here. We've seen Claude Code, but here it is. I didn't have to do anything on my laptop. I just have it. And then we also have some preview URLs to actually preview the application itself. And this is basically the environment that all of our software engineers use. So instead of setting up their laptop, they click a button, they get something, they click into Claude Code or their IDE, and they start working. So what this actually looks like in practice in this particular example, this is kind of the architecture of our environment. I'll show you one other too that isn't what we use, but someone that I met at a conference, kind of what they do for their environments. But the infrastructure layer, this is running on a cloud. This is running on AWS. You could run it on bare metal as well, but essentially we decided that we wanted to kind of run this on the cloud. We're using Kubernetes, so when you click the button, Kubernetes is spinning up a new workspace for you. That becomes the area that you're working on. Coder is our project that actually manages it and gives you the UI and the buttons and stuff. For secrets, we're using HashiCorp Vault. It's a secret manager. There are other secret managers out there. We're using Coder Agents, which is our harness. We have one that you can kind of talk to. I didn't really show that. But we have a little agent here that if I wanted to say, hey, I want to work on something, I could talk to it, and I wouldn't have to click anything. So in this one, I asked it to spin up an environment. But again, this doesn't really matter. This could be Claude Code. We also have Claude Code in there. We're using AWS Bedrock to give people access to AI so that they didn't have to manage AI tokens or anything like that. We're using Bedrock. And I think like the more important part is just kind of what we have in our repo. And that's what I'm going to be spending most of the time talking about after this, which is we spent a lot of time kind of defining the different dependencies that our environment needs so that when you get into that environment, it automatically has Go, it automatically has Python, it has TypeScript, and it has kind of all the dependencies that people need. And it's codified too, so that if we needed to switch to a different language or framework for something, it would apply to the rest of the team and the rest of the environments. We also have an agents.md in there so that when you start prompting an agent, the agent will go down the right path and it'll do the right thing. I could have put MCP and stuff in here too. We have a lot of MCP servers that we use and have kind of defined as well. But again, the main thing is in our repo for the code base, we're starting to kind of declaratively define the different dependencies that we need. I wanted to give an example of a different stack, though, that's totally different. I actually thought this was wild when I was talking to someone about this, but I found it really interesting, which is I was talking to someone who runs I want to say it was like a 150-person engineering organization, so kind of small, not that big, not that small. And he said that basically they sent every single developer a framework laptop, so they had the same laptop. They were using NixOS on it, which is a very declarative way to define developer environments. They were using 1Password for secrets, and everyone worked on a monorepo. They had like a really unique need, for which is why they did this. They were working on kernel modules and stuff. This is very technical and not really the point, but I just wanted to show that there's a lot of ways to kind of declaratively manage these environments. And when you kind of have a like declarative way of handling these things too, I wish I made a slide about this, but you can kind of shift any of them out, right? Like you could shift out framework laptops and do AWS VMs, but because you've declaratively managed the operating system in Nix, you can use Nix for it. Same thing with the password management, whatever. So I think like the point is less let's like figuring out what tech stack to use and more let's start to like define these things as opposed to having it on some like wiki or Joe Knows or Ask Sally or whatever, and to have these things more declarative. And then if you need to migrate, it becomes a lot easier. So for example, if these people needed to start using agents, they'd be able to do so. They would just have to change the infrastructure layer. So I wanted to talk about some things that you can just add into your repo today, and it'll make the dev environment better for basically everyone on your team or everyone that you're working with. If you're working on a project on your own, if you do this, this will make the environment better for the agents that you're working with. So if you're working with Claude Code, this should reduce the amount of tokens and increase the effectiveness of these agents. So again, this isn't necessarily just have to be for if you have a team. If you're working with agents, a lot of this applies too. I think we all know what an agent's MD is, but if not, it's basically a file that you put in your GitHub projects or really any of your projects, and it tells an agent kind of how to work and how the project works. I think a lot of people will overcomplicate this, and I think that's fine. What I think we found to be most successful is any time that we found the agent kind of making the same mistake over and over again, we just tell the agent to put it in the agents.md. We don't write it ourselves, and it's been really helpful for us. So we aren't super fancy with this, but we've seen like some really good results here. And if you don't have an agents.md in your repo, I highly recommend making one. Jumping around, this is the infrastructure template. So I was talking about kind of earlier how we were using AWS and Kubernetes. you can use Terraform to define the infrastructure that developers need. And Terraform is the best way possible to define infrastructure right now. So this is an example of giving people Docker containers with the same exact image every single time. A pattern that we found works really well is you give people an ephemeral Docker container with the persistent volume attached. And that persistent volume allows the developer or the agent to kind of have their work in progress code or any kind of customizations there while still having that like ephemeral layer that can be reproducible. Dev containers is a pretty good specification for also defining these environments and dependencies. This is something else that you can add right into your repo. You can add a devcontainer.json, and in there you can kind of explain the different tools you need. So this is a really basic example where it's using the base image and it's installing something called Mize. But you could see this could also be Java, Python, Go. This is basically one file where you can mention all of the things that your project needs across different languages. And any developer that will clone the repo can spin up a dev container either locally or remotely to kind of have those dependencies as well. Mize is another one. This is kind of an emerging standard, and it's something we've started using and find really interesting. If you aren't super happy with dev containers and you're not super happy with Nix, I would recommend taking a look at Mize. It's pretty cool. It's another way to kind of define what tools you need in a project. And again, it's one of those things that you define it in a file. People will clone the repo. They'll run like a Mize command, basically, and they can get all of the things set up. And when I was talking about earlier, kind of having that one-liner that you can have, Mize also lets you kind of define these kind of tasks that you can run as well. So like a developer task, a test task, and then you don't have to have multiple files defining things. It's really interesting. It's something we've been using a lot internally, and we found it to be a lot better than dev containers and Nix. But you can also use it alongside dev containers, as I showed in the example before. Cool. So now I have a challenge for y'all, and there will be a prize if you do this. Obviously, you don't have to do this. And it's basically just fix one thing in your developer environment. And ideally, fix it in a way that other people, whether that's agents or coworkers or colleagues, will also be able to benefit from. I know it's really easy to be, there's so much stuff going on at work. I have all these like tickets in my sprint, but I really think that some of the most impactful work we can do this year is making our developer environments a lot better and easier for other people. It just reduces like the time that we're wasting. It reduces the tokens that agents are wasting, and it just makes things a lot more clear for everyone involved in your project. This could be as simple as just editing the README, adding an agents.md, adding a dev container. If you want to automate all of the infrastructure for your developer environments too, by all means, go for it as well. But the cool thing is I bought 4 of these little e-ink kind of tablet screen things, and I'm going to be giving them away at the Coder booth. So the first 4 people that do this, just come show me or someone else at Coder the pull request, be like, hey, I improved this dev environment. It could be your project, it could be your team's project, it could be something in open source. I don't know, let's just make a developer environment better. And the first 4 who do it, I'll give out these little e-ink tablets. They're hackable too, so you can really run any software you want on them. They're really small, and I'm kind of selfishly hoping that only 3 people do it so I can keep one of them. But if you do come to the Coder booth, let me know, and we'd love to see it. So with that, that's all I had. That's a QR code for my LinkedIn if you wanted to chat after, but I'll also be at the booth for the rest of the day. We're over at the Coder booth as well, and our GitHub is just github.com/coder as well.
All right, everybody, let's give another round of applause for Mr. Ben Potter from Coder. I hope you guys are able to get the prize, but leave him one. Come on, we can be nice. Leave him one. Ben, thank you so much. Truly appreciate it. Thank you guys all for being here. Okay, I want to check in. Do we need a 7th inning stretch? DJ, do we have a song? I'm kidding. I'm not. Let's stand up. We can stretch around. Oh, we do. Let's go. Let's go. Everybody up and stretch. Come on. Let's go. I'm not kidding, guys. Come on, come on. A little over there. There we go. There we go. Well, now that you're up, we have about 15 minutes until the next session. So we can keep stretching. And also, by the way, this is going to be my last session with you guys today. I will be back here bright and early at 11:30 tomorrow morning. My co-host is going to take over. Just a couple of notes before we get out of here, just for the next 15, I believe. We want to make sure that you know that the IBM Bobathon is wrapping up at 1:45. Is it already 1:45? I think it's about 1:30. Is it 1:30? Okay, so you got 15 minutes if you want to meet some people from IBM there. What is it? Yeah, 1:30. Yep. Yeah. Okay. And then everybody has the Render app on your phone. Yes. We want to make sure while we are here with the fabulous ATL Tech Week, we know that this is day number 4. This is day number 1 of Render. So, I mean, all over Amerismart, there's some incredible activations. There's incredible booths. If you're looking for a job, if you're looking for funding, if you're looking for a co-developer, a co-founder, I mean, there are so many people here from all over the states, all over the world. So make sure that you are going out there, meeting people, talking to people, getting their LinkedIns. Hey, if you want to be on TV, come say hey. I'm here in Atlanta. But thank you all so much for being here. Tomorrow's Jersey Day, so make sure you have your jerseys. And I will see you all tomorrow. Christian Ross is on deck next. Thanks, guys.
check it out and let me know if you need some more.
Oh, perfect. Eric, yeah. Hand chat. Yeah. Wow.
Good afternoon. How's everyone doing? You ready to learn? All right. I like y'all. This is better than the main stage. Keep me over here with AI. Um, well, AI coding assistants are great at small tasks. We all know that. But what do you do when you're working in a complex code base and need to plan out an in-depth feature? I have some questions. Eric Hanchet is a senior developer advocate at AWS and author of Vue.js in action, and he teaches on his YouTube channel, Program with Eric. He's here to show how modern AI coding assistants can break complex work into distinct, manageable phases. Please welcome Eric to the stage.
Thank you. Thank you. All right, well, let's jump into spec-driven development. Before we start, by a show of hands, who's heard of the term spec-driven development? Okay, almost everybody here. Who uses it? Like, okay, half the people. So we're going to talk about what spec-driven development is and how you can use it. But also, since I'm up here and I have some time, I'll give you some of my opinions, just in general, on AI and how I think you should be using it. You probably have seen some themes today on AI, so we're going to deep dive into it even more. So we're going to talk about what is spec-driven development, a formal definition of it, and then also how it can make you code faster. But not just faster, but more accurate, how you can use it in your day-to-day, basically the correctness of the code that comes out. We don't want to just create AI slop every day. We want maintainable code that we can use in the long term. Who like codes every single day? Okay, good chunk of you. So don't worry if you didn't raise your hand. We are going to go over some basics as well. So we'll go over it all. Here is the formal definition of spec-driven development. Spec-driven development is writing structured specifications first so AI can automatically build and test the code. So the operative words in here is that you write the specs first. And it gives the AI a really good idea of what you're trying to do. And why is this important? Now, let me first to say that spec-driven development isn't necessarily needed for everything you're doing, but for large features, tasks, something that takes a little bit more forethought and makes sense to do it. But why do we need this spec-driven development? Well, I kind of think specs are sort of like an AI intern. Well, in this case, AI in itself is an AI intern. What can happen is that you can give it just a little bit of input. I don't know if anybody's done this. You're like vibe coding back and forth, and you just give a small little prompt, and it goes in some crazy direction that you didn't even expect. And that's exactly what happens with most agents out there. I remember the story. I was an intern at one of my first tech jobs, and I was a software developer. And when I went into the office, we had a VP that used to just kind of wander around. I don't know if you had anybody like this at your work who would just like randomly stop engineers and ask them questions and sometimes give them suggestions on things to do. So I'm sitting in my cubicle and the manager comes by and he says, "Hey Eric, the website looks great, but what happens if we change the color here? What do you think about this? What if we added in a button down here?" And me being the eager intern, much like our AI interns, I drop everything and I just start working on it. And then quickly, I find out, like, this is not the right way to do it. I'm in my daily stand-up the next day, and my boss is asking me, our 15-minute stand-up that really takes 45 minutes. Anybody who's been in something like that? And then they ask what I've been doing, and I'm like, oh, I have been dropping everything for the VP. And of course, I learned quickly, like, no, we need planning. That's why we have Agile. That's why we have these ceremonies in place. And that we need to sprint plan. The VP needs to put it on the board. It needs to be delegated out to everybody. So I tell that story because if we don't give the right direction to our AI, we're going to go in the completely wrong place. I haven't really introduced myself, although thank you for the introduction earlier. My name is Eric Hanchin. I'm a senior developer advocate at AWS. I've been doing software development in some shape, way, or form for probably 15 plus years. I started doing QA. I've done Java development, front end and back end. And also was, before I was senior developer advocate, I helped ship code on the Amplify service team at AWS. That's a tool that helps developers ship AWS products on AWS. I won't get into Amplify, but you can also connect with me on LinkedIn. I love to talk to people. I accept any and all invitations. Also, I get this question a lot, like, can I get the slides? I'll put this up here. I have a website program with Eric. If you scan this with your phone, I'll put the slides up there in the future, so hopefully tomorrow. But we'll see, as soon as I can. But I also have like programming tutorials, all sorts of things on there to check out. So we kind of had the formal definition of spec-driven development. And the next question I often get from audiences is like, well, hey, I'm using the latest GPT 5.6. I'm using Fable 5. Can't the latest models just do everything for me? Why do I need this spec-driven development? And it's good, but it isn't great at that point where it can do everything. It's almost like you're launching a rocket ship when you're in software development. And if you're just a little bit off, it's going to go miles away from where you expect it. So if you try to one-shot, I don't know if anyone's tried this. Anybody try to like one-shot a whole app or whole feature, just one ginormous prompt? Okay, a couple of people. And then you get to it's probably going to take a lot of things that you didn't imagine. It's going to have some broken code. In fact, there's tools out there specifically to help you with AI that's for your code base that it's gone through AI and it's broken something. You might have imports that go nowhere or dead code that doesn't do anything. So it's good, but you still need to give it structure, is the point. So this is the fun part. I get to just talk a little bit about how this relates, some tips I would do before jumping into the spec-driven development, because it sounded like most of the audience have heard of it. So here's just a couple of my pontifications. If you're in the last talk, there might be a little bit of overlap on one piece. One is too much context. Spec-driven development is great because you write the specs before any code is actually done. However, we have to keep in mind that anything we do with our agents, that we almost have this Goldilocks zone of too much context or too little context. If you give your agents too little context, so let's imagine you're using your Claude codes or whatever, and you don't really specify anything about your code base, then it's going to get really confused when it tries to do certain things for you. It might not have the same conventions you expect. On the other hand, if you give it way too much context, I know we have models that have 1 million context windows, but it's going to have the same problem. The output isn't going to be what you expected. So you got to keep that in mind. There's actually a whole study on this that said that when you bloat the context window, you have unexpected results. Of course, we all know agents.md, our Claude.md, and steering files. This is really important before we even go into the spec-driven development, which I'm going to show you in a little bit. Just make sure that any of the code bases that you have an agents.md or Claude.md, some way that gets added into the context. Once again, not too big, not too small, but has some more information about your project. Anybody use agents.md, Claude.md in their, I see, most people, good. This goes without saying, use skills. These are like our standard operating procedures. They're like recipes that we can add in. When you start using specs, you can use skills inside your specs. So just make sure that you have a number of skills installed. Like, for example, if I'm using a TanStack Start app, that's a front-end framework, I might install the TanStack intent skills with it. That's a package, NPM package you can install. If you're using something on the AWS side, we have something called, we have a ton of different skills that you can use. We'll just leave it at that. Don't give your, obviously, when we're working with spec-driven development, you are the most important person in this process, as with everything we do. If something goes wrong in the future, they're not going to blame Claude Code, they're going to blame you. So don't give too much trust to the agent itself. Make sure you're doing the minimum of reviewing the code. I've talked to teams recently that have outsourced reviewing code. I don't know, anybody do that? Like, don't review the code? Nobody. I wouldn't do that at this point. We're all still the human in the loop in this, so you make sure that you're reviewing it. Of course, you want to set up your AI code reviews. This is the same thing as you're going through the spec-driven development flow that I'm going to show you later, that you obviously still use AI code reviews in the middle. I think that's perfect. I know some people use GitHub, TaskRabbit, CodeRabbit? CodeRabbit. Two different things, right? Don't sacrifice speed over maintainability. In the future, your future self's going to thank you that you spent more time up front with this. Spec-driven development is this way because we are writing specs at the beginning, almost like we're doing test-driven development, right? Any TDD fans out there? Okay, still some out there. So this is our version of TDD. We're going to create specs and plans before we jump into the code. It's going to take more time up front, but your future self will thank you. All right, so let's change topics for a second. Let's do a history lesson. Now, you might have seen in some of these slides, I have this ghost here. This is the Kiro ghost. We're going to talk about Kiro in a second. This was a product that internally came out of AWS. It's based on some history. So we at Amazon in general have been doing something in the AI space for a long time. Our Alexa agent that has Alexa products, devices have been installed in over 600 million, basically hundreds of millions of homes, 600 million devices out there. And that has been using some sort of agent in the background even before it was popular, before ChatGPT. Amazon.com, same thing. If you go to Amazon.com and you put something in your cart, and then you come back later, it'll be there. And then it'll probably recommend like things that you bought in the past as well, so that recommendation engine. So we've been doing this for a long time. And one thing that we saw is we were talking to customers who were using the latest in Cursor, and I think at that time Cursor, and they kept saying like the correctness isn't quite right that's coming out of these agents, out of my coding editors. So what do we do? And we started telling them, let's create plans. And we were doing it in a manual spot. So we had a lot of our solution architects talking directly to customers, and they would give them this formula of, okay, let's stay, instead of just going directly and kind of going back and forth with your coding agent, let's create a requirements document, a design document, implementation details. Let's have it have a plan before. And we heard that so often that we decided to create our own AI coding editor. We launched it last year in general availability in November. It's called Kiro. A lot of people call it Cairo. I'm not going to correct you if you come later and tell me it's Cairo. That's fine, but it is Kiro. It's our new agentic IDE. When we released it, it was really fun. This is something doesn't always happen at AWS. It kind of went viral. So when we launched it, we had tens of thousands of downloads. We had to put up a page to a wait list because we had so many people downloading it. People found a way around the wait list. It was fun. So this came out as a direct result. And one of the main things we added into it from the start, from our customers, because at Amazon we work back from the customers, was this spec mode, and spec being spec-driven development. And since then, it's definitely gone through some changes, but here's Kiro.dev. You can download this today at Kiro.dev. It's free. You can use a social login. You don't have to have anything to do with AWS. Like, you don't even know anything about it, don't worry about it. You can just download it, try it out today. Hey, and if you stay all the way to the end, only for you people in this room, I have 500 free credits that I'm giving to everyone here. But you have to fill out a survey. So there's a quick survey at the end. So stay to the end. So that was one of the main reasons we created Kiro, is the spec-driven development at the beginning. But it's not the sole reason you may want to check out Kiro. Don't worry, this is not going to be a 20-minute pitch on Kiro, but just a couple of other things. It has web. It's now not just a CLI. It's not just an IDE. It has web. It has iOS, a CLI. And it keeps expanding. We just released an open source product called Kuro Crew, which is really neat. It's kind of like an open claw, but with lots of security built in. So we are definitely changing it. We're definitely going all in on this. But how do you use this without Kuro? And if I didn't explain that right, that is an agentic IDE, just like Cloud Code and the others. And if you want to know more differences, we have a booth, and there's an AWS booth on the main expo floor. Me and some of my other colleagues will be there. We'd love to chat about Kuro and the differences between it and Cloud Code and others. So if you want to do this without Kuro, of course, you can do this in a lot of different ways. Let me show you a few. One is you can just manually talk back and forth with your coding editor. You can be like, please create, here's a prompt, create a requirements document from it. And it would create a requirements document. And then you would check it, and then you go like, okay, let's create a design document based off that requirements document. And then it would create a design document. And then finally, create some implementation details. That's basically your task list that lists of all the stuff in there. If you didn't want to do it manually, there's lots of different projects, and I'm going to talk about a few that I like. There's something called SpecKit. Anybody heard of SpecKit? Okay, a lot of people. I'd love to come up to me afterwards. Tell me how you like SpecKit. There's also OpenSpec, which is another open source project. There's actually skill wrappers. This is crazy. When I was doing research for this talk, some of these frameworks that do spec-driven development, I mentioned 3 documents. You have your design, you have your requirements and implementation. Some of these create like 40 to 50 different documents. I don't know, that's too much, right? I don't know, but if you want to be hardcore, there's GSD Core, get shit done, get stuff done. Superpowers is another one. There's me. I have a YouTube channel. I did a video kind of talking about a lot of them. We even have our own AI DLC. So at AWS, we open source this. You can go to AWS Labs. Remember, once again, you can get all these slides on my GitHub later. But we have a whole DLC workflow, which tells you kind of beyond spec-driven development, where we go through steps on like how do you come up with a feature idea, how do you create documents with Inception, how do you construct it with an editor. And there's a lot of parts to that. In fact, there's phase 3, 4, key artifacts, best for enterprises, regulated environments, greenfield projects from medium to high complexity. Anybody work in government? No government people here. You probably like this, because it does have a lot of data. BMAD is pretty popular as well. This is another kind of spec-driven development type framework. It has a couple different steps. One is the analysis, which is optional, and then planning, which is required. When I did this, it kind of interviews you, which is neat. So it like asks you a million different questions about the feature you're creating, and then it'll go into a planning phase. This can work with a lot of different of your coding editors, so think you can work this with Kuro, but you can work with Cloud Code, a bunch of different ones. And then it goes into solutioning, which is more like in the enterprise track where it can do this special solutioning part to it. And then, of course, implementation. If you really want like spec-driven development mode light, which is not really spec mode, in Cloud Code, we've all used plan mode. You can use plan mode, and then when it's done with the plan, be like, instead of going on and implementing all the things, create a document out of this. Then out of the document, you could go back and forth, update it, and then you could do a goal. Anybody use /goal? It's a kind of a way in Cloud Code where it kind of makes a loop. You can give it a parameter like, please don't stop until all the tests pass in XYZ. So you can sort of do it. I don't really consider this spec mode, but I know I have so many people in the audience that use Cloud Code. I just like to mention it. Loop engineering is probably a little related to this. These terms kind of come and go. You know, if you're hardcore into the space like some of us here in the audience, you probably heard Ralph engineering and the loop engineering. The idea behind this, for those who haven't heard, is that you can engineer your products by using this like trigger, act, observe, stop. In other words, you're giving it specific stop commands, and you have it kind of run in a loop, kind of like recursion, I guess you could say in some ways, maybe more like a for loop, but it would continue on until some stop condition happens, and you can add this to your code base. Altogether, though, all these spec-driven development frameworks all have a few things in common. They obviously all have plan before you code. They're all the idea is that we're going to create documents to feed into our coding agents before we let it just go crazy. And it has a lot about, it's very related to context engineering. We can talk more about what this loaded term is, but it's essentially dealing with the context window of our agents. And the verification is always the bottleneck, right? We're all using these agents, and we need people to do code reviews. And that's a big task, and that's still not solved by this problem. And then finally, they're really not great for small bug fixes. So if you're trying to create 40 documents for like a 10-line bug fix, you've lost at that point. Don't do that. Now, I was trying to see some like real-life use cases, and we have Kiro. On our Kiro website, we have customer testimonials, but I think this is a good one. This isn't using Kiro, by the way. This was at StirTrek, which is a conference that I go to a lot of conferences and talk to a lot of people, and he runs an agency, and he was literally creating hundreds and hundreds of spec files. And the way he did it, every single feature for every single client, he creates a spec file, he goes through the spec kit process, I think he's using spec kit, where he's creating these design, these requirements text, and then in fact, he's taking those designs and all those files, putting them into their own database, and then setting up RAG retrieval. Anybody heard of RAG, retrieval augment? Yeah, a lot of people here. So he's actually using that. So next time you create a spec, it knows, it'll search the previous specs you created, and then it basically helps you create the next one. So I've heard of all sorts of fun things. Everybody has these bespoke patterns that they're doing nowadays. Here's what it looks like. We've been dancing around actually what it looks like inside a normal project, but in Kiro, you would choose the spec side. It looks a little different now. We've updated the UI. I haven't updated these slides, but you give it a prompt, like build a movie MCP server to keep track of movies I've watched. And then it would create this 3 phases. The requirements phase, it would create this document. It's built directly into Kiro, by the way, and the CLI, if you're a CLI fan. And it has this ears format. You can Google what ears is. It's like easy requirements. Always forget the exact acronym. It's essentially a very formal way to write requirements. It's almost like back in the day where everybody's doing that waterfall method of writing things, and you had to do it in a very specific way, like user stories. This is the way it writes it. By the way, you can change that if you don't like that inside Kiro. And then it creates a design document. Once again, you can also skip the requirements and go directly to design. Oftentimes, the different frameworks will do it differently. In Kiro, you can do the same. And design document has kind of like what most people in this room, all us people in the room who do software development love to. We look at architecture diagrams, and we can go through and update those. And of course, always, we're the human in the loop, so we want to review every one of these documents as they're being created. And then we'll get an implementation phase, or basically a task list. A tip what I like to do when I get to this and any of the frameworks or anything I'm doing is I take a look at the task list and I say, let's create an MVP from it. So whatever feature, whatever I'm doing, what's the minimum amount of things I can do to get it looking and I can start basically testing it right away. The worst thing you want to do is have it just go through and implement all the things, and then you're at the end, it's like, well, this wasn't quite what I wanted. And then you have this weird issue where your specs don't match what you wanted it to do, and you're kind of in a bad place there. So I always tell it, let's go ahead and change this up. Let's get an MVP. Let's get a minimal amount of tasks that you can complete first, and I can double check it. I love MCP. I'm a MCP stan, because you could say. If you don't know, MCP is it solves that integration problem between different model providers and data sources and your user applications. So in this case, like Kiro would be, or Claude Code or Cursor. And then you can take your MCP, which is the USB-C port for AI, and then you can connect your user applications to your data sources, and it has a standard, and you can have authentication and authorization and everything built in through there. Last time I did this talk, someone said, Eric, isn't MCP dead? No, it's not dead. Maybe that's also, that was 3 months ago everybody was saying that. For now, today, no one's saying that as often. But I'll just let you know that it's definitely not dead. Skills are, there's a basically, if you go online, there's a skills versus MCP versus story out there, but I think both are great. MCP is good because like that spec is constantly being updated. It used to have some problems that you've heard in the past with context. Most of those problems have been solved. So why do I bring this up with spectrum development? Well, I hear a lot when people start this process, they're like, well, my product guy writes the requirements. Now you want our engineers to write the requirements? No, your product guys can give the engineers the requirements. MCP, just have it connected up. Use something like, have it connected to Asana, ClickUp, whatever your project management system is. Have it being pulled over into the specs as they're being created. So that way you're not having your engineers do everything. Who has their product guys like creating proof of concepts right now and like sending it to the engineering teams? Anybody doing anything like that? Okay, only a couple. I've seen that a lot of people are trying to still figure out what's their development life cycle. And I've definitely seen a lot of non-product people non-tech people creating apps, which is great. Let me show you a quick demo. Since we don't have internet, that I cannot give it to you live, but I do have the second best thing, which is a video, and this is what it would look like inside that. It's kind of small, it's on the bottom left-hand corner, I'm just prompting it. This is the IDE, and I'm like, create a new movie database app, have it in the 80s theme. So I can start basically going through and creating this app. And it's going to ask me some questions like, hey, do you want to skip that design side? Do you want to go directly to the requirements? Or do you want to skip requirements, go directly to design? So it kind of prompts me and asks me what I want. And any of the good spec-driven development frameworks that I showed before will have some kind of variation of this, where it's going to quiz you or talk to you or ask you before it jumps in directly. Then it's going to start working. I'm going to fast forward through here so you don't see it all here, but let's go to the next one. Then once you have it, I have a design document. So kind of fast forward in the future, hey, we got this design document. We gave it kind of a vague prompt just for the sake of this demo. But now we have this really nice doc. It's using mermaid diagrams. That's kind of a markdown standard to be able to create really cool views. Of course, interfaces, if we're using TypeScript, we have them all listed here. And we're like, hey, that looks pretty good. Obviously, at this time, I would go up, back, and forth. And I said, hey, looks good to me. Great. LGTM, let's keep going. So then it creates a requirements document. The requirements document, in this case, it's very formal, like I said. That's in that ears format. Here's the movie validation. Here's what it's good for. Then we are going into the task list. So it said, hey, this is good. Here's a list of tasks. I'm going to say, can you take these tasks and rearrange them to make so the first 4 tasks create an MVP for me to check. So it's going to go ahead and rearrange these. So I have like an MVP. So now I can go in and make sure they're all correct. And it says, hey, I rearranged all the tasks for you. Thank you. And then I said, go ahead and complete all the tasks. And it went ahead and completed all the tasks, and it came up to this. And I wanted this because I only completed the first 4 tasks, but now I see, hey, some of these things don't work, but that's perfect. Now I know what it looks like, and I can test it out. That's the whole idea of rearranging and getting to the smallest piece. Now if that looks okay, I'd be like, okay, go ahead and do all the other tasks. And you kind of see with this process that it's a little iterative. I can look at the code, obviously, that it created, and I could be like, oops, I missed something. Go ahead and complete the rest of the task. Make sure to add an API in. So you kind of iterate back and forth after you get the implementation details. And here it is. Here's what my website will look like when it's done. Now I have all the nice movie posters. I can click on it. I have that nice retro 80s theme to it. Yeah, so it looks good here. Then I also can check test. Here's property-based testing. This is a nice testing standard that we use with our requirements documents to make sure that the requirements are as they are supposed to be working. And that's something called, if you Google property-based testing or something called fast check, both of those libraries will create tests for you that kind of really work really well with spec-driven development. In this case, I made sure it completed all the tests. And here's like a diff. Like, here's all the tests I created. And I'd be like, okay, those look good. For the sake of time, we're going to keep moving. So you want to learn more? You can go to kiro.dev, or we have a Discord channel too, which is something that AWS has never done before now, which I think is really neat. Here is the survey. So take out your phones if you want to. I'll leave this up on the screen for about 10, 15 seconds. This is where you can get, it's a 3-question survey. It's pretty simple. If you fill it out, we'll give you those 500 credits. It'll have a URL. You'll just pop it in to your browser. You can install, you can go to it. Then you can download the CLI or IDE later. And then, yeah, start trying it out. Let me know. I'm in the booth. Tell me how you like it. Thanks. I appreciate it.
Thank you, Eric. I think we all appreciate real world, like the fact you're going through and you can see how to build things. So we're headed to break, and just to FYI, Room 2 kicks off a 3-hour alerts quality management workshop with New Relic, and it started about 10 minutes ago, so stick around if hands-on observability, and if you're trying to observe, go take a look. The words aren't coming out. It's been a long morning. In Room 2, so in Room 2 right there, they kicked off the 3-hour hands-on workshop, and it's using guided missiles to protect spaceships from asteroids. Seriously, that's not a joke. And it ends at 5 p.m. And then right back in this room in 2:30, we are talking observability in the AI era, from complexity to clarity, with 2 senior worldwide specialist solutions architects from AWS. So we'll see you soon. Hey guys, glad to see you here. As we know, modern applications are complex and they're distributed, increasingly AI driven. But why do we keep having this word, observability? It's cool because we're observing, I get it. Tooling, it hasn't always kept at pace. So the next session that we have right now uses the world's busiest airport as a map for fixing that. I'm really excited about this. Ravi Teja and Imaya are both solutions architects at AWS focused on cloud operations and observability. Imaya created the AWS One Observability Workshop and co-authored the AWS Observability Best Practices Guide. Please welcome Rativeja and Imaya to the stage.
No? Does it work? Okay.
Okay.
All right. Thank you. Hello, everybody. Nice to be here. Thank you for being here, by the way. I know it's right after lunch, but please hang in here. All right. So let me start to ask an obvious question to Alexa, right? What's the busiest airport in the world? We all know that. We don't even need Alexa to answer this, right? And yeah, ATL is the biggest or the busiest airport in the world, and ATL handled 106 million passengers last year. And it was actually 110 million just before COVID, so it was even higher, right? And that's a lot of people, and that means a lot of planes. There are about 2,200 takeoffs and landings that happen every day in Atlanta Airport. And think about that, right? And there's very busy runways. There are 5 runways, and et cetera. All right. It's not easy. There's a lot of people. There's a lot of scale. The real question is, how do you actually handle that scale? And you have to be really, very precise in a lot of things for a lot of things to go right in this busy environment. So the answer is by being really obsessed with data, and you really want to collect the right information, the right time, and process it in such a way that you actually get a lot of information out of the data. And your signal-to-noise ratio has to be, in the appropriate level that you get a lot of information out of whatever you're collecting, and in the most efficient way possible, right? Our VP and CTO of Amazon.com, Dr. Werner Vogels, said, no data, no AI, no progress, right? If you don't have the data, and not any data, but I would also say the right kind of data, you really cannot do anything on that, and you really cannot progress from wherever you are. Well, it's the same problem, right? Like, why do they even bring up this airport thing into the picture? It's the same problem. Well, like, maybe I'm actually oversimplifying it. Airport operations, I would imagine, is probably more critical and probably has a lot of things, critical and important things at scale, like human lives, let's say, compared to us operating a few servers here and there and computers, et cetera. But end of the day, if you kind of like leave that part out, but if you look at the core aspect of what is really important in both of these scenarios, essentially we want to provide an environment that really becomes invisible. You really want to go to the airport, but really don't want to actually see the operations and all the failovers and the redundancy systems kicking in and all of those up management things that are happening around you. You would just want a pleasant experience. It is very similar to what your customers want from your applications. They don't want to know that an API, is failing and erroring out, or there is this higher memory or a CPU utilization in a certain server, or somebody actually didn't show up at work, and whatever, right? So you just want a smoother experience at the lowest cost possible, and just essentially give a great, business environment for innovation to flow through, et cetera. That's the ultimate goal. The goals are similar. That's why I'm drawing those lines together. Let's look at what is the foundation for all of these things, right? Many of these things may not necessarily be new to us, but I just want to ensure that I level set what we are even talking about. Whether it is your applications that are heavily using AI agents to function, or whether it is a monolith or even a microservice environment, you have to collect telemetry from your applications, from your workloads, whether it's infrastructure-related things or application-related things. You really need to know what is happening. It could be just a couple of EC2 instances on AWS, or it could be a bunch of servers. It could be a lot of Lambda functions or EKS and Kubernetes clusters, et cetera. No matter what that is, you just need to know what is happening. So you can actually take action if something happens in that environment. To do that, you essentially collect logs, metrics, and traces. Logs are essentially just the age-old kind of telemetry data that we've always been collecting. It has a timestamp. It really tells you what exactly happened at that timestamp from a specific application or a process, and you send it to a storage location so you can kind of make sense out of that thing later on. And then you have metrics that are basically time-stamped or a time series information, in other words, that give you some perspective on certain things, like typically the general example is CPU utilization, memory utilization, et cetera. Not only those infrastructure-related things, but also business metrics as well. You could be instrumenting your application to collect custom metrics such as how many searches were performed, what were the searches that were mostly performed on this application, and what was the request latency like for this particular workflow. And those kind of business metrics that you would typically want to report to your business. Those are custom metrics that you would collect. And then we get into traces. These are a little more advanced, and for good reasons, we all like to build microservice-based architectures these days. And the reasons, there are a lot of positives there, and you really want to have your teams have higher velocity in terms of shipping software. It also allows your teams to be kind of polyglot. They can build the language that they are familiar or comfortable with and that they can move faster with. And you can scale horizontally very easily compared to building a big monolith and then iterating on that. However, those are the advantages, but the disadvantages that we have is that you suddenly have a lot of moving parts in a application, and then those really kind of cause a little bit of a challenge when it comes to knowing what exactly is happening in your application. If your application is slow, you really need to go to find out which particular microservice caused that particular sluggishness. It could be a particular change that somebody made in that microservice, but many developers are not even aware of the change even happened because they don't even own that piece. That's where traces come in. That essentially allows you to connect all the hops that your application makes, your specific request makes in your microservice environment to put the whole picture together so you understand what exactly happened in that request. In our jobs, we actually talk to hundreds of customers every year, and this is something we see all the time. Like, customers have multiple observability solutions that they have set up, either through acquisitions or individual teams. They're having their own autonomous decision-making power, so they go acquire their own observability solution. So data is kind of siloed everywhere. Not only the observability data is siloed, sometimes it's also because the application workloads themselves are hosted in different environments. Some on AWS, some on other cloud providers, some are on-prem, et cetera. That is causing more and more kind of challenge for customers to get that whole picture of like what is exactly happening in their environment. That resulting in higher resolution, higher kind of time in identifying issues and resolving, and so on. So if you look at again, going back to the ATL airport situation, you can kind of draw parallels there too. Like, you have at any given point the multiple teams owning actually different things. In the control tower, you could have a ground control that is solely responsible for vehicle movement on the ground, like guiding the aircrafts moving from the gate via the tarmac to the runway, and then again planes that land on the runway from the tarmac to the gate, and also other non-aircraft movements as well. At any given point, they need to know what exactly is happening on the ground. And there's another separate team that is the air traffic control that is responsible for all the vehicles that are in the air, which is airplanes, right? And within a 5 nautical mile radius, they really need to guide the planes that want to land and also guide the pilots that want to take off, et cetera. And there is also another team called a radar control that are a little bit away. They control aircraft movement outside of this at traffic control area. So you can see all these different teams, they have different kinds of visibility into their own area. However, they need to know, they need to have this proper handover mechanism. They need to know that a specific aircraft, what path that aircraft took and from where and et cetera. There needs to be coordination, end of the day, right? That is really critical. And that is where it becomes really important for you to get that full visibility, right? And when I say full visibility, when we see green, when something looks green, that doesn't always mean that it is all healthy. Have you heard of this watermelon situation, right? You have this green that looks, and then when you cut open, it's actually red. So what we mean by that is, say for example, in this dashboard, you see, if you're looking at departures, right? See departures, and then everything is green. All the aircrafts are departing on time, everything's great. If that is the only metric you're looking at, the airport is functioning perfectly. But when you look inside, TSA is backed up. Maybe the plane train is not actually on time. There's something else going on somewhere else. The passengers, they're not even boarding the planes, but the planes are taking off on time. So you could assume that everything is great, but there are no passengers on the planes. They're all missing. So there's a lot of chaos. So it is really important for you to really dig deep inside and actually find out what is happening. So in order to do that, you really need to correlate a lot of different information, right? And that's why you also need to have this in a microservice environment. You really need to find out where is that specific delay, right? It could be a flight that you're taking from point A to point B. Us living in Atlanta, we probably are not taking too many connecting flights, but there are people who don't live here who travel through Atlanta who are taking, it's a hub because it's one of the biggest hubs in the world. And sometimes when you travel internationally, you're taking multiple hubs. But if let's say your planned travel is like 5 hours, but actually it took 9 hours, and one of the hops is 4 hours, unless you know which hop took that that time, you really wouldn't take the most optimal connecting flight. Similarly, when you look at a trace, when you look at an application request, when I talked about a microservice environment, a trace is the one that's giving you that visibility into what specific microservice caused the latency, high latency. Right? So that's the one giving that information for you. So you can dig deep in and find out what happened in that application. So when you look at that trace, when you see a specific application, a specific microservice that is causing that delay, what you would want to do, you want to look at its metrics, you want to look at its logs, and for that, you have to be able to easily correlate and find out what exactly happened. Well, I just talked about like what exactly to do and where to look into all these details. The how part, like what you need to do to get to where you need to do. I invite Ravi on stage.
Awesome. Thank you, Maya. Now that you have seen the challenges, how do we fix those challenges? So the answer to this is let's begin with collecting the telemetry. How do we standardize collecting the telemetry? The answer is open telemetry. So think of open telemetry as a USB-C for your telemetry. Before USB-C, you might have seen Lightning, you have micro USB, you have USB-A to connect to different devices and charge different devices. So that's a big chaos. But USB-C solved the problem for you. Similarly, before 2019, before invention of the open telemetry, if you want to evaluate different vendors, you would need to write in the vendor-specific SDK, vendor-specific agents, and then send the telemetry to the backend. Imagine, after 6 months, if you want to evaluate a different vendor, it would be chaos. You have to rewrite your entire code, and then it may take hundreds of engineering hours, right? So that's where OpenTelemetry can standardize with one SDK, one agent. You can evaluate multiple tools at once. You can send to multiple backends. This way, you're solving that vendor problem. And with OpenTelemetry, the correlation comes built in. You can see the adoption rates here from 2019 to 2025. You can see the 10x increase in the adoption from the customer enterprises. Now that you have started collecting the telemetry, remember, not every signal that your application generates deserves a storage in the backend. So this is where you need to be proactive and cut that particular noise. This is where the telemetry pipeline can help you to cut those specific noise. Imagine you have 3 different environments, development, UAT, or production. Not every log or not every trace from the development you need to ship into the backend, and that you would be using again to investigate the issues, right? So telemetry pipelines, you can either set it up on the collector end, which is the client end, Or if that vendor provides the server-specific telemetry pipelines, you can set that up in the server end. So let's see the paths of the telemetry pipeline here. Once the raw signals are flowing in from your application, the first step is to filter the noise, which means you can customize your verbose from, let's say, if you don't want info, errors, warnings, you can just cut it to errors. And the second, enriching those signals. You can enrich the specific signals with your business attributes. For example, you have a certain type of customers that you want to query later. You can inject attributes such as customer tier, business unit, service names, and so on. And third, processing. And imagine you have a use case where you need to redact your PII, like input prompts or output prompts, before injecting into the telemetry backend. This is where you can process that particular telemetry. And the fourth, this is the important piece to cut down your bill, where you need to be smart about shipping the frequent versus infrequent signals. For the frequent signals, you can ship it to the hot store, and the infrequent signal that you query the least, you need to park it into the archive. So this is the telemetry pipeline that we're talking about. What are the advantages? You can see the observable bill with this particular telemetry, you can slash down your cost by 40 to 60%, improve your query speeds, and you can reduce your MTTR. And next, once you have the clean data in place, so how do you know what to measure? What are the right signal to measure for your application? So typically, we think from inside out perspective, since let's say we are like DevOps engineers or AI ops or platform engineers, we start from the infra, then application, and then maybe AI agents, and then we'll think about the digital experience or the user experience. But that's not true always. We should start thinking from outside in perspective. What exactly I am promising to my customer? That should be your measuring point, like the starting point. So first, I would start with your business SLA. Identify what are your business SLAs that you are promising to your customers. From there, define your service level objectives. And then identify the right service level indicators on how to measure those service level objectives. And then the number 4 and 5, I talked about standardizing the instrumentation using OpenTelemetry. 4 is using OpenTelemetry SDKs. And the number 5, using the OpenTelemetry collectors. And then set up your alarming. And then whenever there's an incident occurs, you need to do that COE process. In Amazon, we call it as correction of errors, where you write a detailed documentation on why that incident happened, when it happened, how to mitigate it, how to avoid it. And then learn from the incident and reiterate the cycle. So this is a cycle you should be thinking around when you want to pick what are the signals that you need to measure. And then once you have all the signals in place, how do you connect the dots? This is when instrumenting with OpenTelemetry pays off. OpenTelemetry provides shared semantics across all the signals. For example, in the traces, we do have a trace ID that you can inject in your logs where you can correlate the logs and traces. Same way, there are shared attributes like host name in the Kubernetes that is injected across all the signals. With that, you will be able to drill down from application to infrastructure to database. You can correlate all the signals across your infrastructure. And also, you can inject a business attribute, like custom business attributes, where you want to query in a business perspective. And next, all we have talked about is doing the manual work. Imagine you are an on-call engineer, got paged at 2 a.m. in the morning, and you need to investigate an incident, and you have to correlate all the signals. It can take, quote unquote, like 30 to 40 minutes just to investigate the incident, let alone it may take like 10 to 15 minutes to verify, and maybe like 30 minutes to deploy the fix, right? So this is where, in the era of AI, how about handing over the investigation part to the AI, where it can correlate all the signals like observability, not just observability, maybe security logs, audit logs, compliance logs, code deployments, everything, and it can provide you evidence with the key findings and the root cause and the mitigation plans, maybe with just in like less than 5 minutes. And then all you need to worry about is verifying the fix and deploying the fix. This would solve like huge amount of problem like lowering the MTTR, which can save a lot of your business downtime, and it can increase your resolution time from like speed from 3 to 5 times. So everything we have just described, starting with single control tower, universal instrumentation, picking up the right SLAs, telemetry pipelines, and the autonomous investigation is possible today with the help of Amazon CloudWatch and AWS DevOps Agent. Think of Amazon CloudWatch as like your true unified observability platform. So everything you run, infrastructure, application, AI agents, databases, digital experience, network monitoring, everything you can inject into one single layer where you can collect and you can enrich your telemetry and you can do some advanced analytics in the language of your choice. You may use like SQL, PPL, and CloudWatch native login sites QL. Or you can use, for the metrics, you can use PromQL to do that advanced analytics. If not, you can use our natural language to query your telemetry. And then we are providing the flexible tooling as well. So in case if you want to bring in your custom tooling that are compatible with Apache Iceberg format, we do provide the same data in the S3 tables in the Apache Iceberg format, where you can just keep the data in the CloudWatch, but can connect to a different tool and do that analytics. And next, AWS DevOps agent. Think of it as your AI teammate. It's an always-on agent. Whenever an incident triggers, it will go ahead and investigate the signals for you, correlate all the signals, provides you a hypothesis with a root cause, with key findings, and a mitigation plan. All you need to do is to verify and deploy the fix. So let's see both of them in action in a quick small demo here. So how many of you are aware of OpenTelemetry Astronomy Shop demo here? Have you ever played with this demo? I see only one hand. OK. So this is an upstream OpenTelemetry demo. It's a typical astronomy shop where it has like multiple microservices, like checkout, payment, and so on, where you can buy products. It's a sample demo. What I'm doing here is I instrumented this entire application with OpenTelemetry SDK. And then I'm using OpenTelemetry collector and deployed it in my Kubernetes environment and pushing the telemetry to the CloudWatch. Let's see how this application looks like or how we can visualize within the CloudWatch here. So this is my CloudWatch console. So the entire application and the related dependencies and the related microservices are mapped together within the CloudWatch. And you can see here. So I have a front end, I have a proxy, which is connecting to different microservices, which are all interconnected here. And each of the microservices, you can get the golden signals, which we call as like requests, latency, false, and errors, everything here. And the next step I did is set up a service level objective to one of my microservices, in this case, payments. My goal is I want my payment service to be available 99.99% of the time in the rolling 28-day window. I set it up here, but however, it is not attaining the SLO. You can see there is 25% breached. So let's see how we can investigate using the DevOps agent here. I'm going to switch to DevOps agent. This is the DevOps agent interface. Within a plain language, you can just task. Let me type it out here. Can you investigate what's going on with my payment service? I didn't provide any context at all about my application. First of all, whenever you enable the DevOps agent, it tries to map the entities in a topology here. So I do have like a bunch of applications. For example, this is my OpenTelemetry demo. It did map all the dependencies so that it knows what to investigate when we ask a question. And then similarly, I have some of the AI agents within a Bedrock, connected to different sources here. Let me show you an example of an incident that already occurred. So this is the same question that I asked earlier today. Can you investigate like errors in my payments service? What it did, it picked up, there are two payment services in my CloudWatch. One is from the OpenTelemetry repo, and there is one more application called PetSite, where I do have two payment services. And it investigated all the logs across those two applications, metrics, traces, and even the containers. And then it figured out there is something going on wrong with my OpenTelemetry demo. And then it investigated a log volume. It went on investigating my pet set application, not just OpenTelemetry demo. And then after all the findings, it gave me this root cause. It was so intelligent that for this demo, I simulated a workload to intentionally fail the service, and it actually detected my intention as well. OpenTelemetry demo feature flag intentionally failing payments. And it gave you the entire reason what exactly went wrong, how many errors, and what is the baseline, everything. And if you go to the root cause, and it will give you what is the impact to your application. And again, if you induce some business context, it can gauge the impact on your business as well. And it will give you the root cause with the key findings and a mitigation plan here. Right now, it couldn't find a mitigation plan because this is an intentional demo. But again, if you have a real scenario, it can give you the mitigation plan. Not only that, it can learn from your past investigations and past incidents and can suggest you some improvements. For example, there is this improvements where I'm running every week. It looks at all my previous incidents and previous investigations, and it can categorize the improvements in terms of infrastructure, governance, and code optimization. So it will suggest you what you need to do in terms of optimizing your environment. So this is about DevOps agent. I'll call upon Imaya to share some closing thoughts and how you can scale this together.
All right, thank you, Ravi. Okay, so it's so easy, right? Now, all you need to do is just go back to work and just do these 3 steps. I know we are oversimplifying here. I mean, if you ask me to do it, of course I would, it's not going to happen on just this Monday, like I say on this slide. But the thing is, with auto instrumentation, which is a way that you can actually collect all your telemetry from your applications without really making any code changes, it is kind of possible, right? Yeah, at least in the lower environments, not in the production environments, you can do that. Essentially, auto instrumentation is something that happens with this configuration, and in a kind of some SDK or agents that get attached to your application process automatically when the application boots up, and that collects the telemetry, like spans, etc. And you can collect information out of what exactly is happening in your application. So what you do is just maybe do that. Maybe you cannot actually write code and instrument the application. Of course, if you have AI agents, you can do that as well. It's pretty straightforward. Just ask it to do it, and it'll do it for you. Or you can just go do add an auto instrumentation agent. Set up a pipeline recommended, but maybe not on that Monday itself. But in the long term, you would want to set up a pipeline that really allows you to enrich the existing data that you're collecting. Make use of the standardized data model that OpenTelemetry allows you, because everything is standardized there, and it's much easier for you to kind of create correlation and enrich the data while you're ingesting and collecting and ingesting the data itself. And then obviously, DevOps agent makes it really easy for you to kind of find the root cause and solve all the problems for you. So I would say just give it a shot. When you go back and just try it out, it's probably much easier than you think, or than it has always been with the help of AI. And if you want to learn more, there are a bunch of resources that our team actually has put out. The first one is the One Observability Workshop that we sort of created. It's a real-world, hands-on microservice environment that has EKS and ECS and Lambda, API gateway. You can imagine all those kind of things, including an AI agent, Bedrock agent code, et cetera. All these things put together in a microservice architecture, and that can simulate a complex real-world environment that already collects metrics in OpenTelemetry format and PromQL, et cetera. It's a hands-on thing. If you have an AWS account manager, talk to them, and they can actually set up a workshop for you on their own dime. You don't even need to use your AWS account for that. And if you are already into the journey, you can look at the observability best practices guide that actually goes through a lot of scenarios, patterns, etc. Gives you specific guidance on what you can do to improve your observability. And on top of that, we have an enablement series, which is almost like a weekly thing that we do. Many of our team members present multiple use cases, case studies, and they go very deep into specific areas like containers, serverless, or maybe AI observability, etc. And it's a hour-long session. It's free. It's online. You can just join. You can learn. You can ask questions and connect with us on a regular basis. It's a calendar that is available. Having said that, I hope you liked and you got something out of this session. Thank you so much for being here. And please feel free to scan that QR code and give us feedback. We really value that a lot and helps us improve. Thank you.
Thank you both. That is a blueprint everyone can use Monday morning. Well, just FYI, over in room 1, Uber is talking AI policy and governance at global scale, and you'll have Uber's Sean Perryman and Alvin Huntspan talking about aligning AI policy and governance with global product development and how fairness frameworks turn into real product decisions. And then we'll be right back in here in 15 minutes talking Prism, building the AI-ready UX stack, and also using AI to build it. So we'll see you in 15 minutes. All right. Well, super excited for this next one. At Uber, they built Prism, a unified UX engine that makes interface components directly invocable by AI assistants. It powers Uber's conversational support experience across riders, eaters, earners, and merchants. Shantanu and Kunal both work on Uber's customer obsession engineering team and lead the work behind Prism. They're going to walk us through the architecture and how they're using AI itself to build it faster. Gents, welcome to the stage.
All right. So quick show of hands. Who here has tried to build a UX with AI agents, for their AI agents sometime this year? Right, quite a few of you. So then some of the things we'll talk about here, you might find it relatable. So yeah, let's get started. My name is Shantanu.
And I'm Kunal.
And today we'll be talking about Prism, which is Uber's UX stack powering the conversational AI support experience that we are building. And we'll also talk about how we are using AI to build and scale. So yeah, let's get started.
Let's do a quick summary on what we are going to talk about. So let's look at the left-hand side. You will see there's like a big wall of text. This is basically how most of the support agents look nowadays. There's all the accurate AI information here, but is buried within a whole paragraph of text. And now if you look at the right-hand side, you will see the same information being shown to the user with widgets. This is why we want to explain why we are trying to build a widget system for conversational AI agents. 3 things are happening here. Text and presentation are being combined to show a rich interactive widget. Scannability is helping you build confidence. At a first glance, you can see exactly what this is trying to convey. And there are guided paths at the end of the widget. These guided paths, for example, cancel an order, contact the restaurant, show you that Uber understands the situation that you're in. And it also helps you not having to type everything, but just being able to tap to take the discussion forward. A high-level takeaway is that we are not only making the UI pretty, we are also reducing the effort that it is taking for you to understand what the answers are, as well as what to do next with the conversation. I'll hand over to Shantanu for explaining Prism a bit more in detail.
So yeah, Prism is the foundation for scaling Uber's conversational first support UX, user experience. So what it does, it unifies the widgets, actions, and rendering. So it is this UX which is powering end-to-end help experience and our AI assistants as well. So it essentially is like a shared library which can be used across different apps. So we have like multiple different apps, rider, eater, couriers, merchants, and so on. And so you build once and you use it everywhere. So it lets you build this abstraction where you centralize all the styling and actions and making the updates very seamless and lets you iterate very fast. So why do we want to build this now? Why are we building Prism now? So Uber is reimagining its support experience in a conversational first world enabled with AI. So we used to have these screen-based automations and support experiences where the user would have to navigate through multiple screens and get the experience that they need. We are now trying to reimagine all of that in a conversation-first world, and we are doing this with widgets in chat via LLM agents. So what we want to do with this is expand across all different use cases, and we want to leverage the efficiency that AI provides by creating agentic workflows, which will let us to have faster velocity while maintaining the consistent Uber user experience. So what's our bet? The way we want to do it is orchestrating UX at runtime. Let me elaborate. So let's start with the backend side of things. Where Prism sits in the stack. So you have a user query that comes in. It reaches our conversational AI agent. This AI agent is able to reason through what the user is talking about, and then it will figure out the intent. Then we have a policy execution layer. So it will figure out which policy to execute. Then after running through all of these workflows, it gathers all the data it has, and then it knows that it has to respond back to the user. Once it knows it needs to respond, then it will invoke the appropriate widget tool. So this widget tool is specific for a specific use case. So for example, you want to present refund status information or like the fare breakdown to the user. So this widget tool is going to fetch the appropriate data along with some of the data that the LLM has supplied, map it to the widget schema, and then return a typed payload. Now this typed payload is something now our Prism layer understands. So Prism is the shared UX engine which will take this typed payload, enforce some additional styling and validation, analytics, and so on. And then you get the same experience across all the surfaces. So your iOS, Android, web, and our internal tools as well, where we use to debug different issues or the view that the agents see as well. Everywhere they see what the user sees. So let's zoom out a bit. How is this widget tool, quote unquote, sitting in the stack? So this sits alongside all the other tools that the AI agent can invoke. So conversational AI agent has a tool registry. So Prism widgets also sit in this registry next to all the other kind of tools. So for example, you have the action tools, which will be saying that, hey, figure out the user's intent, retrieve some content, execute the policy, maybe hand off to an agent. But when you want to respond to a user, these widget tools would also sit alongside where the conversational AI agent can figure out that I need to choose this particular widget tool to serve this particular query that the user is asking. So you might see in the screen, there are some use cases listed where if the user is talking about a refund, we have a specific kind of widget for refund. If they're talking about fare breakdown, or if you want to get the rating from the user, or if you want to talk about order status. And we have many more, but some, for example, here. So what that lets us do is separate the policy from the presentation. So the policy execution layer doesn't need to worry about how this data is going to be presented to the user. So they just need to take care of what is their specific use case and what's the most appropriate way to solve that issue. So again, taking the refund status example, the policy execution layer is going to execute the user query, and it figures out, hey, for this user, I have a refund that is available, and we have already issued the refund, and this is the status for the refund. So these are the facts, and this is what it gives to the conversational AI agent. Now, the conversational AI agent is able to convert that, invoke the respective corresponding widget tool, which will present the same data in this very rich UX that you see on the right. So this has the information of, we are processing your refund, this is in progress, this is the status. So as you can see, like the policy layer doesn't really know or need to understand how this data is showing up for the user. That is the job that the conversational AI agent and the widget tools do. So, so now to tie everything back together, we have to now understand a little bit more on the front-end side of things. So for that, I'll hand over to Kunal.
So now let's get a bit deeper into how the front-end stack works. A quick show of hands. Who here has played with Legos when they were growing up or even recently? Oh, everybody. OK, amazing. So let's, even me too, by the way. But yeah, let's take a minute to think how Lego works. So Lego basically has a set of standard bricks. They are different shapes, they are different sizes, and you snap them together to build something that you want. Be it a mansion, be it a spacecraft, be it a house, be it whatever. The bricks are finite, and the bricks are the same across. The assembly or the composition is basically what gets you all these new different structures. So basically, our front-end stack is sort of modeled the same way, and which we'll get to in the next slide. So yeah, our front-end is built up of composable primitives. They are components like rich formatted text, buttons, progress steps, banners, etc. These are basically those bricks that we build once and we are reusing everywhere. And there are a few container-based components, like a card or a grid, which is basically the skeleton or the wrapper inside which we are snapping all these bricks together. So now tomorrow when product comes and says, we want an order status widget that you see on the screen, we will not spend time writing the whole front-end code from scratch. We would assemble primitives, for example, a progress step to show the status of the refund, or something like a button to show the guided CTAs at the end of a widget, or even a tag to show when the order would be delivered. This basically means there's no new rendering code. It's just the assembly that will be needed to ship this widget. This is exactly what helps our system scale. Once you have enough Lego bricks in the bag, more and more widgets are essentially free from any front-end code. Just the assembly, the compositions, and making sure that the UI looks right will all give you like this range of distinct widgets solving distinct use cases. Actions work a similar way. So actions are decoupled from presentation on the front-end side. So tomorrow when you want to compose a widget with actions, let's say that we want to choose a selection action or a navigation action or something to open a bottom sheet to show more content. You can snap the corresponding action with the widget UI to make sure that you get the widget and interactions that you want. Next slide. Yeah. So one thing that you would also probably see when you're building this AI managed UX is that widgets sometimes outlive their context. They end up becoming stale after a certain period of time. So let's take an example where a user is trying to contact the restaurant. The order is being prepared by the restaurant, so we've given the user an option to call the restaurant to ask what is going on with the order. Let's say 10 minutes from now, the order state has moved forward. Either the courier has picked up the order or the order got cancelled, unfortunately. At that point, still showing the widget that says contact the restaurant doesn't really make sense anymore because that state has passed. But the user will still see the widget somewhere in the history of the conversation. Now, if they tap on it, they would either go to a dead state or they would go to a state where the restaurant can no longer help. So the user will not get the help that they want. So now how we solve this is we put a brain into the widget. These brains are basically encoded contextual rules that help the widget understand when to show up or when to be taken out or when to clear themselves. These are encoded into the definition of the widget itself. For example, if the user decides to type on the keyboard instead of making a tap, it shows the user is signaling that they want a separate path than all these widgets, so the widget should end up clearing themselves. Or secondly, if I have a bunch of 4 or 5 options, and I tap one of them, I've shown the intent to select. That signal will just say, the rest of the CTAs are not valid. Let's hide them, otherwise you might get to a combination which nobody wants to get to. Just a quick note though, we are not taking away these options from the users. If they show the intent again, we would resurface those options with the fresh context. And that's the high-level idea of this piece. Next slide, please. Oh yeah, now I'll hand off to Shantanu to take on one example end-to-end so we see all of this in action.
Yeah, so now that we understand a little bit of how this is working on the front-end side, and we talked a little bit about the conversational AI agent being able to take the context and invoke the respective widget tool. So now this is the slide that will tie everything together. How is the backend communicating with the front end? So everything on the left, you see the contract, and the right is how the widget is rendered out. So, so now we understand some of the components that Kunal talked about. So you see in this case, there's a refund status widget, which has this. So let's split it down into 3 things. One is what's the UI, how the widget looks like, what is it composed of. Then the data itself, what do you populate that widget with. And then actions. Are there any actions that the user can take on the widget? And then there's the optional thing, the analytics and lifecycle. We'll come to that. So, so the UI says this refund status widget is composed of this rich text. It has a status. There is some progress bar, and there is a action button as well. Now the data is what the widget tool populated over here. So in this contract on the left, you can see we construct this layout, this template, and then we populate it with the data where we say the refund is processing. There's a progress bar saying it's an in-progress refund, and it gives the state of each state that we obtained from the data layer. And then there's an action button, which is the view receipt, and we have attached a deep link action. So if the user taps on it, we take them to the receipt screen where they can view the complete receipt. So, so this is, all of this is configured from the backend, and front end understands all of these primitives. So we just compose them together, supply everything, and then front end just needs to run through each of them and render it out. Additionally, you see at the very bottom, we have the some lifecycle elements and analytics as well. So additionally, we can also plug in analytics data. For example, for refund status, you can supply some additional data that backend has and frontend does not. So whenever the widget is rendered or interacted with, frontend can emit analytics along with the analytics metadata that we sent. And then there's the lifecycle component as well, which indicates how this widget should behave when the user moves past that point in the conversation onto the next message. So hopefully this helps tie back some of the things that we discussed. And now that we understand everything, let's quickly run through a recap of this front end and back end working together. So the user asks, where's my order? This reaches our conversational AI agent. It figures out this is an eater, which is trying to ask about an active order. And for this order, I need to convey the order status to the user. So it chooses the order status tool. So this order status tool, it knows that it is pertaining to eater and for live order context. So this order status tool is this widget tool, which will pull the live order and courier information. The LLM will also supply some of the information that it has, and then it will fill out the widget template that is pertaining to order status. Now, for this, based on the status of the order, there might be some actions attached. So in this case, we are showing that user has an option to contact the courier. So it will attach that where they can chat with the courier as well. It reaches the front end, and then the widget that you see on the left renders out, which is the super rich widget, which shows that the order courier is on the way, but because there is some rain delay, the order is getting delayed, and it shows the contact courier button, which the user can tap on it, and it will open the contact courier chat, where they can chat with the courier. So all of these things were just composed with primitives. The respective tool took care of that particular use case. And for front end, they didn't need to reinvent the wheel. Everything was built once, and then we reused it everywhere. So yeah, that's the conversational AI side of things and the Prism stack. Now we'll hand off to Kunal again to talk about how we are using AI to build and scale.
Yep, so that's the big second piece, like how can we make this process fast? So basically, we have to answer, can we onboard these widgets fast enough? So at the scale of Uber, which has millions of support sessions across rides, eats, drivers, and merchant apps, we have to ensure that we are able to scale hundreds of widgets here. So the question is not, can we build widgets? Yes, we can. We saw an entire example end to end. The idea is, can we build this fast enough, which is where AI comes in. So AI can basically help us look at every piece of the widget onboarding process that you see here and help us accelerate each and every one of them individually. So what we've done is we've broken down this into 4 distinct sections, like discovering something, designing what to do with the widget, developing a widget, and finally delivering it and shipping it or making it shipping ready. So at each phase, AI is able to gather the requirements, build the code scaffold, be able to wire analytics, be able to grade or compare the output against the mock that we have for the designs. It's able to do all those repeatable steps very, very easily. Where the engineer steps in is to basically handle judgments, something like an edge case or something like a new capability which we haven't added yet, or even something like a business logic which needs to be added. The idea is that we have to scale multiple different widgets in the couple of months. We have already embedded AI into our code bases. It has all the context that it needs for naming patterns, for component conventions. So tomorrow when the first scaffolded code is output by AI, it basically already understands the team patterns that we have end-to-end, so it is a little bit easier to manage as well. So that's the first idea. Let's get into a little bit more into how the quality is managed. In the next slide, yeah. So for quality, we want to definitely ensure that if we are shipping faster and if we have speed that we want, we don't trade it off at the cost of quality. We have to ensure that we are able to grade widgets. Grading for us, how we envision it, works across a bunch of different dimensions. There are like 7 to 10 dimensions. I've highlighted a few of them here. Something like spacing, typography, color, Uber branding, the ones that matter to us the most. The idea is a widget has to basically score at least 95% across all of this. Of course, it will of course trend closer to 100% as systems mature. This is just an arbitrary number right now. There are a few hard gates like accessibility because we don't want to miss out on those. If it fails accessibility, for example, the entire widget would fail and not ship, regardless of whatever the rest of the scores are. The unique thing I want us to take away here is we don't only apply this grading process once, we apply this grading process across various different life cycle items of a widget. For example, when we are onboarding widget and we have the scaffolded code, we would apply this before shipping. If the score doesn't match the threshold, it will not ship. Tomorrow when we have capability enhancements or tomorrow when we have new code being added, we again want to run a grade to ensure that no regressions have come in and we are able to find them all before we merge any code. And the third is the real-time conversations. When widgets are actually being pushed to users, making sure that the grade does matter or does hold accountable in those real-life conversations as well. That's also important. So it's not a one-time thing, it's a continuous thing which we keep grading our widgets on. That's like the high-level takeaway. I will hand off to Shantanu for talking more about where is Prism going to go next.
So, yeah, where are we going next? So phase 1 is where we are right now, which I described to you. We have a widget exposed as a tool, or different widgets exposed as respective UX tools for the LLM to deterministically pick, and the widget tool kind of taking care of how to populate the data and supply it back to the front end. What's the natural evolution of this is what we are working towards is getting the LLM to populate the widget contextually by itself. So we want to expose every widget attribute as a per field like metadata that the LLM can read and interpret and then supply the data to the widget. So that's the next phase we are working towards. Once we are able to do these two things, the natural next step is for LLM to be able to pick best fit widgets and even compose them together, multiple of those if needed, into a truly personalized response that we can surface back to the user. So yeah, those are the natural evolutions that we see this taking us. So if there are 3 things that I would summarize what we can take back from this presentation that can be in general, we can apply across, is number 1, give AI a bounded canvas. So for Uber, we operate across 70 plus countries and 10,000 plus cities, so across different jurisdictions. So it is very important for us to roll out whatever we do in a safe and secure way. So while AI can do a lot of things, we also need to ensure that the deterministic pieces stay deterministic, whatever we can control, and the one where it can truly shine, we let it shine. So, and for that to happen, by limiting partly what it can do and then taking control of the pieces that you want control over will help you get there. Number 2, making every support experience feel personal. So separate the policy from the UX. The user experience library can be built in a scalable way so that AI can then truly leverage that individual elements to be able to personalize how we surface it back to the user. So what you do the ground level helps you build incrementally and let the LLM deliver a truly personal experience. And finally, like Kunal mentioned, we work at a scale of millions of support requests coming in every week, and we have so many different use cases that we want to tackle. So we want to scale faster as well, and that is where AI will become your companion. So you need to be able to organize the code base into and split it into repeatable workflows, which the AI can take over, and the agents do most of the work. The engineers step in where they are really needed to. So that's how we can deliver and ship much faster. So yeah, I think that was all that we wanted to share today. Thank you so much. If you had more questions and you want to talk more, we are there at the Uber booth today and tomorrow. Happy to chat with you and share more ideas. Thank you so much.
Well, that is a serious look at building AI platforms at scale. Thank you. And you know one thing I love that I wrote down from your slide? The agent drives, engineer steers when it drifts. I love that. That's a good take on that. So FYI, thank you so much for your time and your insights. Room 1 has software factories coming up at 3:15, and we're going to close out the day right here with IBM and Red Hat at 4 o'clock in 15 minutes. See you soon. Okay, there's shoes. I see her. I don't see Dave. Hi, I'm Christian. Nice to meet you. Good to meet you. I'm getting ready to. Oh, wait a minute. So it's not Robin?
No, so Deepa is going to start, and then she's going to introduce the rest of our team.
Got it. Okay. Let me change. Is she in the front? She's in the blue. Okay, thank you. I'm Christian. I'm doing the intro, and so wanted to confirm who is coming up.
Oh, I was just going to introduce Dave, but if you're going to do it, I don't.
Dave, McDonald?
Dave McDonald. Yeah.
Hi. I was literally sitting there. Okay, I didn't realize that was you. I'm sorry.
So I was just going to come in and say thank you to everyone for coming. So I'm the senior state exec for IBM.
Okay.
And that's all. I wasn't going to talk for very long.
Well, I was going to say, thank you first. So why don't you come up as I'm saying thank you, and I can pass you the mic, and then you just pass it back to me.
Perfect. Alrighty.
We can go up now. And then I'm going to call it you and, so will Robin be?
I'm going to go through the slides and then I'll bring Robin up and we're going to do like a little dialogue.
Christian, nice to meet you. So lost in all of this. Okay. Deepa. Got it.
Not that we have to.
Welcome, everyone. We are so glad to see you here. And before we get started, I want to say thank you to IBM. They are the presenting sponsor of the ATL AI Expo. From the Bobathon this morning to this closing keynote, IBM's been all over this floor all day, y'all, all day. So first, I'd like to have Deepa from IBM come up.
Hi, everyone. I know it's the end of a long day, but I assure you that what you're about to hear is really going to be material because it's going to help you change how you think about security and securing your environment. And we've got fantastic speakers for you today. So thank you for joining us, and really big thank you to Red Hat, our partner and co-sponsor of this, as well as Arrow, also sponsoring with us. And I am so delighted to have Dave McDonald here. He's the SVP of Red Hat Americas joining us, and really, really glad to have him join us on this important topic.
All right. Good afternoon, Atlanta Tech Week attendees. I'm thrilled to have the opportunity to talk to you today. So myself and my presenting partner, who will be up shortly, Robin Hernandez, are going to talk with you a bit about how we're going to help companies secure the open source supply chain. And AI has really, really impacted that. So let me start by kind of giving you a quick intro to who Red Hat is, if you've not heard of us before. So Red Hat is the world's leading supplier of open source software solutions for the enterprise. So we work with companies of all sizes. We deal with more than 90% of Fortune 500 companies use Red Hat solutions. We've got about 21,000 employees all around the world. And we were one of the very early open source companies to go public, first to reach $1 billion, first to reach $3 billion in revenue. Last year we did about $7.5 billion in revenue and continuing to grow at double digits. So we like to think that our clients vote with their dollars, and they've said, hey, Red Hat, you're adding a lot of value with what you're doing in the open source world. So because Red Hat was founded out of the open source community, the culture of open source is the culture of Red Hat, is the reality. For those who don't know, and I'll talk a bit about open source, there are more than 1 million open source projects in the world right now. I've seen numbers that listed as high as 5 million. Nobody knows the exact number, but it is certainly over 1 million. And what open source is all about is a group of people come together and they're trying to solve a problem they've identified. So they collaborate and they write code that solves this problem, right? It's a very collaborative, it's a very transparent process. And they make this code available to the world for free, right? So it's different than the proprietary process that has existed for years, and it tends to be something that drives really innovative solutions and enables them to move really fast. And these open source communities can be as small as a handful of people or as large as having millions of contributors. So an example of that would be like, if you're familiar with Kubernetes, which is container management. You had literally millions of people contributing to the Kubernetes open source community, as well as big companies like IBM and Google and Red Hat. So these communities can get quite large and really create unique solutions that a lot of people get value out of. Now, we think open source is beautiful in that this community development model drives brilliant innovation, it drives rapid iteration, but what those communities create is not always consumable by companies, because companies may need some additional things added to that code. So what Red Hat does to take open source community code and turn it into products that can be consumed by the enterprise is things like quality assurance and integration. So for example, in the world of AI, there's a lot of great new open source projects going around, things like VLLM or LLMD that really add value to the AI ecosystem. But for instance, we'll help out by testing those new technologies on things like NVIDIA GPUs or AMD's upcoming GPU technology. So we make sure that the quality is there, that the products work. We provide a predictable life cycle for support. So 10 to 15 years of support. So when a company deploys this technology, they know they're going to have experts available to help them. So if the engineer or the developer who brings this code into their company today and starts using it, retires or leaves and goes somewhere else, they've got Red Hat backing them up with the expertise in those code sets and those technologies. And also, when our clients want something added to those open source code sets, to those products, we can add it, and we have great relationships with what we call the upstream communities, the open source communities, where we can add those enhancements so that you're not on a forked version of the code. You're using the current code that's available to everyone. So those are the type of things that Red Hat does to make open source consumable within the enterprise. I mentioned more than 1 million projects out there. We're integrating and stabilizing those projects, and this is kind of the value of why big companies, Fortune 500 companies, will work with Red Hat to help them do this. Now, certainly we can't work with all 1 million plus open source communities, but we try and pick the ones that are most applicable to the challenges that companies are struggling with. So our portfolio consists of infrastructure technology. So probably the most well-known would be Red Hat Enterprise Linux. There's a lot of different Linux distributions out there. There's things like Rocky Linux or Oracle Enterprise Linux or Ubuntu. Well, Red Hat Enterprise Linux is kind of the most widely deployed version of Linux out there when it comes to private clouds, or in many cases in the big hyperscaler public clouds like Azure and Google and AWS. So very, very widely used Linux product. We also have a version of Kubernetes called OpenShift, which allows you to manage containers and also do VMs or virtualization on that same platform. It also provides development tooling. In fact, we've been rated by Gartner Group as one of the top cloud-native development platforms for the last 4 years in a row. We do automation capability, so we help you deploy and configure software by creating runbooks so you can automate those processes and eliminate manual errors. And we're doing more and more in the artificial intelligence area now. We're helping people who buy GPUs, NVIDIA GPUs, to manage those environments, optimizing the utilization. In fact, worked with a client very recently that had bought some GPUs. These are very expensive infrastructure technologies. They brought them in and they tried to run those GPUs the same way they would work with a traditional x86 server, and they were only able to get 10% utilization on these really expensive GPUs. So we put the Red Hat OpenShift AI technology on that platform and got them from 10% to 52% utilization, driving a huge return on investment for those clients. We also help them do things like leverage what are called open weight models. So what's an open weight model? probably most of you are familiar with like ChatGPT from OpenAI or Claude from Anthropic. Those are very, very large language models. And they're very expensive to use if you use them at scale. But there are free models out there. You can consume these models from places like Hugging Face, so things like Meta's Llama or Mistral's models. Recently, a lot of Chinese models like DeepSeek and Kimi K. These are much smaller models, and they're open source models that you can actually consume for free. In fact, within Red Hat, we use AI extensively throughout our business to run our business, and about 85% of our model usage is open weight models, because we found that we can get answers that are just as accurate and just as fast, but at a much, much lower cost by using these open weight models. So those are the type of things we're doing from an AI perspective. Now, again, I kind of said clients vote with their dollars. As you can see, we've done quite well in providing these technologies to companies. So we have 100% of the airlines in the Fortune 500 use Red Hat technology. So local one here, Delta Airlines, very big user of Red Hat technologies, and they really used Red Hat to accelerate their move to cloud. 100% of the US executive departments, 100% of the Fortune 500 telcos, virtually every 5G network that's in place today runs on Red Hat's technology. 100% of commercial banks in the Fortune 500. So across the board, huge client set that's getting value from open source. And I was talking earlier about, kind of the open source culture. It's really important to us. At Red Hat, our values as a company align with those open source communities. So the engineers who work at Red Hat, I mentioned we have 21,000 employees. We are a very technical company. We are a hands-on tech company. So ironically, I run sales for the Americas. And although I run sales, 82% of the people who work for me are hands-on keyboards technical people. That's the value we bring to our clients. And we live by, like, when you join Red Hat, you don't have to sign a thing that says, hey, any technology you develop while you're at Red Hat belongs to Red Hat. We want you to contribute that technology to the open source communities. Like, we believe the transparency, the democratization of this technology is going to make the world a better place. So our values are freedom to contribute, accountability to solve problems for your colleagues and for the world. And these are things we believe deeply in our heart at Red Hat. Okay. Interestingly, there's been a massive change in the security landscape that our clients are dealing with, especially since the introduction of Anthropic Mythos. So many of you probably have heard of Anthropic Mythos. Anthropic announced they had developed this technology and said, it's too powerful for us to release. And in fact, in a matter of a few hours with Mythos, they were able to discover about 25,000 vulnerabilities that existed in open source software. In fact, some of these vulnerabilities had been around for 30 years and nobody had ever found them. So that creates one challenge. Another challenge that was created is, with these newer, more capable models, not only can they find new vulnerabilities, but vulnerabilities will be kind of ranked. Are they low severity, mid severity, high severity? These models like Mythos are able to understand, can I string together or chain together multiple low severity vulnerabilities to create a high severity, high risk issue? So they can do that, right? So if you go back to just 2018, was it, about 8 years ago, it would take a hacker typically about 2 years and 4 months to exploit a vulnerability in software. Today, a conservative estimate is, with this technology, they can do it in under 10 hours. So your bank, your insurance company, your healthcare provider, just 6 or 8 years ago, they had 2 years to close a vulnerability. Today, they have a matter of hours to do it. So this creates a huge problem. And what people don't realize is, big companies, they'll buy software applications, so they might buy things like Salesforce, buy products from Microsoft and IBM and Oracle, and those companies provide patches for their software. But companies also build their own software. They build products to solve solutions that are unique, that there maybe is no application to address, so they build their own software. Well, their developers will often go out, they don't write every line of code themselves. They go grab open source packages to speed the time to create an application for themselves. So the reality is about 60 to 70% of the application code that companies use today is open source code. So the challenge is now you have things like Mythos and other large language models that are finding these vulnerabilities. So how do you secure it? It's not a lot of great options, honestly. So you could try and build all those patches yourself. Reality is probably many of the developers who built those applications are no longer in your company. And some that, even if they're there, they may not really understand the details of that code well enough to write the patches. And they may not have time to do it. You could say, hey, we're not going to build any more code ourselves. We'll just buy packaged applications. Probably not a realistic solution. And you certainly can't say, I'm just going to accept the risk. In fact, the reality is, when a vulnerability occurs and it's exploited by a bad hacker, there's reputational risk, there's financial impacts. It's really a dangerous situation. So clients came to IBM and they came to Red Hat and said, can you help us address this problem? This is a huge pain point for us. And our answer is called Lightwell. So IBM and Red Hat have always provided patches for our own products. So at Red Hat, we always provided patches for Red Hat Enterprise Linux, for Ansible, et cetera. IBM always provided patches for their products. We've now made the decision and the offer with Lightwell. We are going to provide patching for all open source code, even the code that is not our products. So in other words, thank you. This is a fairly massive undertaking, as you can imagine. Remember, I said there's a million plus open source projects out there. So we're starting with Java, Python. As soon as we finish those, we're going to get to Node.js, and then we'll kind of go through the path. We're even going to do patches for open source things based on Microsoft's .NET and other technologies. So big project. It's about a $5 billion investment on our part. We're dedicating between IBM and Red Hat 20,000 engineers to do this work. But the reality is they don't do the work on their own. They're leveraging AI to create these patches. Right? So it's really kind of an interesting project. We're very excited about it, and we think it solves a major problem. It doesn't solve the whole problem. So, and by the way, we introduced this just 1 month ago. On the day we introduced it, we had 6,000 patches written. Today, a month later, we have 8,700 patches completed. But our goal by January is to get to 100,000 patches. Now, the patches are one piece of the solution. The other thing we have to do is help companies be able to roll out patches into production much, much faster. So what am I talking about? The average company, the average mid-sized to large company, it takes them on average 45 to 90 days to deploy a patch. Right? So imagine you keep your money in a bank. There's a vulnerability in the software they use. Think about that exposure. So we're helping these organizations design newer processes to move from we do patches once a quarter or we do patches once a month to we do continuous patching. And this is really going to be kind of the holy grail of having access to the patches and then having a way to get these patches from a repository into testing, into development, into production really, really rapidly on a daily basis. So that's what we're doing with Lightwell. Super exciting. We actually are coming out with a tool within the next week where companies will be able to upload the software bill of materials or the list of packages they use, and we will match and provide to them the list of patches we have for the software they have in use. And by the way, another really interesting thing is usually when a software vulnerability is patched, the patch is written only for the most current version of the code. What we've decided to do is not only patch the current version, but go back up to 5 versions earlier, because most large companies actually aren't running on the newest version. And the challenge is if we only patch the newest version, and they try and move to that patch, it could break their production environment, right? So this is another kind of unique thing that we're doing between Red Hat and IBM that we think is really important to large enterprises. Now, how will this work? There's two different types of memberships for Lightwell. So the Lightwell Network membership, I'll start with that, very straightforward. You basically pay an annual fee, you get access to the library of patches. Super straightforward. But then we're offering something called Lightwell Clearinghouse Premier. It's a little bit more expensive, but what it provides is companies can scan their own environment, and if they identify vulnerabilities, what we call novel vulnerabilities, things that nobody else has discovered that are vulnerabilities, they load it into our Lightwell library as a request. We provide a service level agreement on how long it'll take to fix it. We create that fix for them, and what we do is we take that fix and we give it to the Lightwell members for 14 days before we go roll it up to the upstream community so they can deploy these patches before any of the bad guys know the vulnerability exists. So that's kind of the strategy there. And all the patches we create after that 14-day period, we roll up to the open source community so it gets then made available to everyone after that. Look, our goal with this project is to be the trusted AI cyber partner for companies everywhere. And look, I think the reality is you don't have to work with us, but there's not a lot of great options because the reality is if you try and upgrade, you could break production if you don't have these patches for the earlier versions. You probably can't write them all yourself. You certainly don't want to be on a forked version of the code. You create your own patch, and if you can't get it to the upstream community eventually, you'll be on a forked version of the code, which creates problems. So we're trying to solve all those problems for clients. But I want to point out, again, as Red Hat and IBM try and take a community view, we're doing some other things. So we have decided to make Lightwell available to 185 research universities for free. Several of these universities are actually in Atlanta. I don't have the list off the top of my head, but if you go out to Wikipedia and you search on R1 research institutes, there's 187 or 185 of them in the country. They're all going to get Lightwell for free. We've sent a letter to the president of every one of those institutions and said, you've got it for free. We're also going to do the same thing for another 100 non-governmental organizations, so like charity organizations and so forth, because these organizations don't have the level of funding that a Fortune 500 company has, but they use a lot of open source code, and we want them to have the same level of protection because we think it's important from a community perspective. Now, what I'd like to do next is have my friend and colleague, Robin Hernandez, come on up. Robin, and I want to talk to Robin a little bit about what IBM Consulting is doing from a security perspective. So Robin, grab a seat and we'll talk.
Testing 1, 2.
Well, why don't we start with tell everybody a little bit about yourself and what your role is in IBM.
Sure. So we have two major business units in IBM, IBM Technology and IBM Consulting. And I've worked on the technology side along with Dave for over 20 years. My role now is on the consulting side of the business. And in consulting, we basically are the services arm, if you will, of the company. And we do consulting engagements on strategy and management, operational management for basically corporations and government entities. And my role is kind of a unique role. My role on the consulting side is to make sure that we use IBM and Red Hat software and hardware, bringing the best value to clients that we can. So I like to sometimes say that I'm the marriage counselor at IBM, making sure both of the business units are working well together, and ultimately making sure that our clients are receiving the best value that they can.
Fantastic. So one of the things I know IBM does is annually they produce a report called a cost of the data breach report. So let's try and say, how big a problem is this? Give us a little insight from cost of a data breach. When a client has a vulnerability that gets exploited, what's the cost? What happens?
Well, we've been doing this report. This is our 21st year. It was just released recently. And so this year is a massive change, as you can imagine. The impact of the AI frontier models has really been the focus of the report. So the average cost this year has gone up at least 12%. The average cost for any one data breach in a corporation is $5 million, just under $5 million. And that's huge. That's a big number that a lot of companies cannot absorb. The AI-related data breaches have gone up this year 56%. Now, the good news for any of you guys out there in the security field or even AI developers, every corporation that we have interviewed as part of this study, 85% of most corporations are investing more in security due to the AI frontier models. So the market is growing, and there's lots of opportunity for students and people in this field.
Absolutely. So if you're a student, those AI skills, those security skills, there is a big market looking for you and your help.
Big market.
Absolutely. So tell me a little bit, I know Red Hat's done a lot of work with IBM Consulting. Do you have a lot of people certified in Red Hat and certified in AI?
We do. So we make sure that all of our consultants have a basic knowledge of what Red Hat does, but our deep practitioners and certified Red Hat consultants, we have 4,000 of them globally. And they love to get certified on the technology, use it with our clients, but I think one of the things they like the most, they're developers themselves a lot of times. They're implementing for clients applications on OpenShift, for example, and using Ansible. And I think they appreciate that as they implement with our clients and they learn things from those client engagements, they also are contributors to the open source community. So they have an open door through the open source project to then feed those things that they learn at client engagements into the Red Hat product.
Okay, wow, that's impressive. And I know as an IBM stockholder, I listen to your earnings announcements every quarter, and Arvind's always talking about AI bookings, and I think he's talking about your group, IBM Consulting. Understand billions and billions of dollars of backlog for AI work now, right?
Absolutely. We have a huge backlog. AI and consulting, we're one of the largest consultants really focusing on AI. And really our work with Red Hat, we have a couple of client examples. You mentioned Delta, which is one locally here that we all know. And I'm sure if you live in Atlanta, we all fly Delta Airlines. It's the easiest way to fly in and out of Atlanta. A few years ago, we worked with Red Hat and Delta Airlines to modernize some of their applications on OpenShift onto the AWS cloud. And so for a huge number of the airplanes that you fly on Delta, if you're using Delta Wi-Fi, chances are you're using technology Red Hat on AWS cloud that was developed with IBM Consulting. So it's a real practical example of one of the solutions we built together. Another one that I like, you know, we all work in tech. If you work in tech, sometimes your role can be somewhat disconnected from the real world, if you will. But I love to always talk about some of the things that affect all of us. We work with companies too, like the California State Medicaid services. And when we modernize in the same way, modernize applications for them, it really affects the lives of people in California on Medicaid. They can receive access to services much more quickly by leveraging their applications on OpenShift, on IBM Cloud and AWS Cloud. Those Medicare and Medicaid patients get access to services more quickly, and the providers, the doctors, can check eligibility and make sure that they're getting their claims processed more quickly. So just a couple of examples of our everyday life and how we use Red Hat technology in our consulting engagements.
Wow, that's super cool. I was talking to somebody from IBM recently, out of Mexico actually, and we collaborated together down there. And the equivalent of like the Social Security Administration in Mexico, IBM Consulting worked with them and put all the applications onto OpenShift and made them all available so you can interact to get your retirement benefits from your phone. You don't have to go into an office or fill out paper or even use a browser anymore. So it's super, super cool. So this Mythos moment was big news. You know, you see it on regular news channels, on business news. What are you hearing from clients about that Mythos moment?
So we've had a huge uptick in inquiries in security. And it used to be that the CISO, the Chief Security Officer, or the CIO was the one responsible for security in the enterprise. But because these same AI agents that are autonomous, that we love creating, we're creating to automate our work every day, those similar autonomous agents are not just causing the data breach or finding the vulnerability, they're causing huge impact to the business once they find that vulnerability. So that's really causing the security conversation to move from a CISO or CIO conversation to the CEO level and to the boardroom. And so we're seeing a lot more inquiries, but the people that are coming to talk to us, and really the fear that is created right now, is moving up to the senior levels of the organization and even the boardroom. The CEOs and CIOs are asking us, how do I have this conversation with my board to say, I am protecting our business, I'm looking out for the vulnerabilities and making sure that we are also using AI to make sure that we can remediate any vulnerabilities and limit the impact to a data breach.
Okay, yeah, I was out to dinner with a client last night, very, very large manufacturer, and they said, all our budgets are frozen right now. The only thing we can spend money on is how do we improve our patching process? Yeah. And I know, I had mentioned, I think, to the folks earlier, usually takes 45 to 90 days for a company to roll out a patch. How can IBM Consulting help people with that?
Yeah, so this is really where we love being the only consulting company within a technology company. This is where this plays to our benefit, really, because the way, just as malicious people create these vulnerabilities, malicious AI agents are also creating and exploiting those vulnerabilities. So we have to attack these malicious acts through AI and automation. And in IBM Consulting, we use technologies like Lightwell, of course, from Red Hat, but we also use technologies to find the complete business impact, like IBM Concert. It will tell you, based on that open source vulnerability, what other APIs are connected to that open source project, how many pieces of a client's custom application would be affected because they can get from that open source project to other pieces of code. So IBM Concert will help us find that vulnerability. And then we use tools. Hopefully some of you went to the IBM Bob-a-thon earlier today. We also use IBM Bob to then make code changes and updates to make sure not just the open source vulnerability is fixed, but the entire impact to the application and to the business is really repaired and preventing from the damage to be done much broader than a data breach. So we're really happy that we are a consulting company within a technology firm because we can leverage that AI and automation software to help us reduce that window of when someone can have a bigger impact to the business.
Yeah, I think that's the biggest thing we can do for companies right now in this mythos moment is really help them get their arms around the problem, define how to be more agile, how to be faster, and it sounds like you've really got the people who can help do that.
Absolutely.
Yeah. So we've only got a few minutes left. What else do you want the audience to know about IBM Consulting or just broadly about the AI space?
Yeah, so I mentioned that we had the Bob-a-thon today. Hopefully you guys have met some of our people here at the conference. We do have a huge presence here in Atlanta. We also have, especially for a lot of the developers that are here, we are running our Tech Exchange conference for AI engineers, developers, infrastructure engineers, and Tech Exchange will be hosted here in Atlanta. So beyond the conference today, and if you want to know more about Lightwell or Red Hat, you can always go to our website and social media, but we hope that you'll also look into Tech Exchange and considering meeting us. Tech Exchange is all about hands-on labs, so it's really about practitioners. It's our most technical conference, and it'll be here in Atlanta in October.
Yeah, excellent. I think we got the slide up here. October, was it 26 to 29?
26 through 29, yes.
Excellent. Well, I have to tell you, Atlanta is really becoming a major tech hub. So at Red Hat, our big annual conference called Red Hat Summit, we did that here in Atlanta just in May. Of course, you got Atlanta Tech Week, and we've got IBM Tech Exchange coming up. It'll be a similar type of content, really hands-on technical session. You should look into it. You can get certifications on many IBM products, great networking opportunity. So kudos to Atlanta for really becoming, I'm going to call it the tech hub of the Southeast. And I understand you play football here, too. I'm not sure if that's, if anybody knows anything about that, but.
Oh, Dave.
All right, well, hey, I want to thank everybody for coming out today. I appreciate you staying. I know it's late in the afternoon, and you stuck it out with us, so thank you for doing that. Robin and Deepa and myself are all going to be here for a little while. If you want to come up and ask any questions, we're happy to chat with you. But thanks for coming out, and enjoy the rest of the conference.
Day. That's a wrap on day one of the ATL AI Expo. Thank you all for building with us today. The Expo floor closes at 5, but of course Atlanta Tech Week keeps going, so check the app for activities this evening, and we'll see you back here at 11:30 tomorrow for day 2. Have a good one.